All right. I've got a big project here. This is a little bit an off my usual schedule stream, but the goal here is something that I need to get done for stuff I'm working on. And it's so annoying that I thought I would share it, partly so that I don't have to do it alone and be annoyed. And, stream helps to boost morale when you're programming through some nasty stuff, but also because I think getting all of this stuff sorted out is something I'd like to be able to share the results of my exploration as I go, um, so that maybe someday someone else who runs into the same issue won't have to do quite as much as I'm gonna do today. But here's the setup. So I've got my base layer, which I've shown in lots of YouTube videos, and it's on my Git repository on git.mrforth and all of that. And I want to use that base layer for some different program projects that I'd like to build, like something like a text editor maybe, or something along those lines, a DAG editor, visual programming, or something like that. Different ideas. Not entirely sure which project I'm going to end up fully invested in, but what I do know is that I'm going to want to use my base layer to make something like a customization system, kind of like what I did in 4Coder. And so it's not going to be good enough to just build an EXE. I'm going to want to have EXE and DLL working together, possibly multiple DLLs. I might be talking about building a plugin system with what I do next. That's on my mind a lot. So in order for that to work, I need my base layer to actually work across the boundary of two executables. And there are reasons why that is a little busted right now. So for instance, I have a log stream that is a little bit, it's not just a print standard out, it can be redirected in lots of different ways, but one of the things it can do is gather up an internal buffer of the log from a certain section of code. And because right now that can work as, I can have it compiled in one object and have multiple objects linked in statically. But what I can't do is have an EXE and a DLL that both use the same log, because if I use my base layer in both of them, they each instantiate their own copy of the log. And so when I call the function to log through my base layer, it's logging to the instance of the log data structure that is bundled in with that executable binary. So what I want is a system where I can have one of them that lives in one spot. Maybe it lives in the EXE and the DLLs all borrow it. Or maybe there's a DLL that contains all the base layer stuff that needs to be shared, and then the EXE and other DLLs borrow from that. Something like this. I'm not entirely sure what architecture I would want. But just the basic low-level problem of figuring out how to organize that is a little bit annoying too, and I'd like to find the best way to do it. So today, my goal is, because there are ways to do it. It's not a question of if it's possible. The question is, out of all the tools available, what is the least painful way to organize something like that? And so I'm going to go through a bunch of options that I have. I did some searching yesterday on the internet, and pretty much the answer is the internet doesn't know how to answer this question in a useful way. It knows how to point you to the very basic surface level options, but it doesn't actually know how to hold your hand through the real problems, like what I just described. And so I'm going to have to just go through and dig this information out for myself, and then hopefully I'll make the guide that can hold anyone else's hand through it. And so that's why I wanted to stream it, just to capture everything I learn along the way, and to start the process of unearthing these esoteric pieces of information. So that's our goal. We're starting now. Here's the big to-do list. Let me move my editor back into real editing mode. So this is what I'm going to work on. I'm actually going to move this to a different file, because sometimes I close 4Coder and open it and I lose my scratch. So let's move all of this to a little to-do.txt right here. Okay, and you can see I'm in this research folder, Lincoln Load. That's what we're working on. So we're going to start with doing this in C. So I'm doing this without any of my base layer stuff. This is going to be pure C, so that we're just studying the problem in isolation from all the quirks of how I've already organized my base layer and my code base. This is not about my particular code base. It's the general problem of how this works in C. So we're going to just start with being able to build a program, and make sure that we are able to see that program run. All right, so there's our hello world. Let's set up build locally here, and this will just build main.c. Let me set up my vsplit, so I should be able to do that. All right, and that should have, yeah, populated the folder with some garbage. Well, not garbage, it's the thing I actually want, but it's not text files. Usually I sort all of the build artifacts out. But there we go, hello world. So I've got a hello world. What we're gonna want is we want that to live side by side with something like library.c. And you know what, I'm gonna rename these already. Just because I'm not trying to figure out how to abstract it yet. I'm just looking at the basics. So this is the Win32 version of the experiment. Separately, we'll do a Linux version of the experiment, and then finally we'll talk about, you know, add that to the to-do list. Single abstraction for managing across both. If I can abstract this problem across Windows and Linux, then I'll be pretty confident that I've built a system that'll work for pretty much every operating system. Most things that aren't Windows tend to work similarly enough to Linux that you can just make that assumption. The few exceptions that don't fit into either of those are still similar enough to the general idea that if they're viable operating systems at all, you can make it work. So Windows and Linux really feel to me like the two test cases that matter. Okay, so we're going to build by building Win32 main and by building Win32 library.c. I think the flag for this is LD. Let's test this out. If I build, let's call this libbegin and have it hello from the library. Right, and then we're gonna bring in Windows here. We're gonna load library A. Well, let's hold on. Let's build this. Right. Okay, so that output a library called win32 library.dll. So I think I should be able to load library on that. And then get proc address on libbegin. We want, let's just do this nice and clean. Libbegin. Libbegin equals libbegin. How do you feel about that? Farproc differs in parameter list from... Right. Let's build a little helper macro that will help us load these things. So libbegin will look like this, and then we'll do... we can pull this out like that. And we'll do get proc, and we'll give it the variable, the library, and the name. And so here what we have to do is we're gonna cast, we're gonna take the address of V, cast it, and then dereference it so that it'll be the correct L value type, and then get proc address on the L and N. Right, so this just becomes like this. So here what we're doing is we're saying, fill my libbegin pointer. Don't worry about what type this thing has. I'll automatically cast it to look like the type you're looking for. I'll take the library I've loaded and the name of the procedure I'm looking for. And let's see if it likes that. Okay, looks like that built. And so over here, Interesting. So I see hello world. I don't see lib begin. Well, let's take a look through remedy then. Not open. New. Set the command to link and load. Oh, right. I ran the wrong executable. So we've got remedy set up, but I think what I need to run is win32 main. Oh, no, not win32 main.c. Win32 main, hello world, and then pause and fail. Okay, let's take a look at that. Oh, another thing, when you build, you have to tell it that debugging is happening. And now we come in here at hello worlds. Does it get a library? Don't show me disassembly. It gets a library. It did not get a lib begin. Okay, I know why. Here we need the decal spec DLL export. So this piece here, I'm pretty clear on what this does. This is one of the two ways, or one of the several ways you can tell the Microsoft compiler that this symbol needs to be visible inside of, or like from the outs. It needs to be exported. So you binaries outside of this DLL need to be able to look into this DLL and find this symbol. So if we build that way and run, there we go. Hello from the library. So that's how you create a library, and that's how you load it and call into it, right? Now, what we need is a test case where there's a single system shared by both of these. So let's say, let's start with the live in exe shared to DLL case and focus on that and try to get that working using each of these options. So if it lives in the exe, then we're talking about, I need a data structure that lives here in the exe. So let's just say it's going to be the single x, right? And the goal will be to get changes that occur in single x on the executable side to appear here in the library side, right? And vice versa. So single x equals this, single x plus equals 1, hello world, single x equals single x plus equals 1, single x equals that. Okay, so this should be busted, right? If this worked, what it would do is go print a 0 increment, print a 1 increment, print a 2 increment, right? But what we're actually going to see is print a 0 increment, print a 0 increment, print a 1, right? So that the busted case is 0, 0, 1. The correct case is 0, 1, 2. So it should be busted right now. And there it is, 0, 0, 1. So let's clean up the noise. We don't need anything else here besides just those that are actually testing the situation. So if we get this doing what I want it to do, this will look like 0, 1, 2. Now, it might not be possible to get it to work right on top of a variable this way. It might need to go through a function. Right, so what we could do is say there's going to be a function that lives with single x called the print and increment. Right, something like this. And print and increment will do this. And so now the goal isn't that the variable itself is visible on both sides. The goal is that this function is visible on both sides and that they both share the same single x variable. That's the more realistic goal. So it's still busted, but if we could get to the point where this was actually, where we didn't declare this variable at all, and this function symbol here, this call, was actually a call into this function, then we'd be good. Okay? So one way that I understand this is supposed to be possible is with this thing called DLL import, and I'm pretty skeptical that this solution is actually going to be right. But I want to play with it because I want to understand what it's doing, because there's this phenomenon where if you look something up on the internet, you get a bunch of people telling you how to do it through something like DLL import, and I think it actually doesn't solve the problem very well, or maybe at all. I'm not quite sure, but it's hard to explain why. Like, it's hard to not get caught on trying to make this work if I can't explain what's busted about it. So I think what should maybe be possible, according to the way people say this works, is that if I export this one, then I can import it here and it will understand to link these two, right? Except when you actually try to do that, it then says unresolved external symbol imp single print and inc referenced in function lib begin. So this is while we are trying to, why don't we, let's take a quick break to clean up our build script a little bit more, make it a little bit more, make the output a little bit more readable. Okay, so we build the library and we get this error here in the attempt to link win32 library.c, which is that this symbol, so underscore underscore imp underscore, is a prefix, but single print and inc is our function name. So that must be coming from this, right? This is the spot in the library.c where that symbol originates. So putting DLL import here must be telling it that really we're talking about a symbol with this name. And you can see when I call it here in lib begin, it's actually making a call to this symbol, right? And it's saying that that symbol is missing. So what I'm going to guess now is if I were to look win32 main.lib, right? So right here, there's a thing called win32 main.lib. Now, what I'm guessing is that when we generated the exe, it generated this lib with it because of the fact that we have a DLL export. So let me go in, I'm going to make another script here called clean. And clean is going to get rid of everything that is an exe, everything that is a PDB, everything that is a lib, everything that is an obj. What else do we have here? Everything that is an exp, exe, obj, pdb, exp, ilk. Okay. There we go. So that got rid of all the build artifacts. And the reason I wanted to do that is I want to see if I build again, then win32 main does generate this lib, right? Now if I clean again and I say, hey, in this file here, let's not do an export, how does that affect the artifacts that we get? All right, so now you can see I didn't get a lib. So that confirms my suspicion. The lib is coming from the DLL export. Okay. And what that means, the reason I'm looking at that is because this is missing a symbol, right? This library isn't building because it's missing a symbol. The symbol it's missing has been prefixed, right? It's not actually named the same thing I named it. So it's been modified. It can't be the case that they expect me to link to this to something that I hand write with this modified prefix. It must be that they are generating the thing that it's supposed to link to, Where are they generating it? They're generating it in the .lib that comes out of this. That's my hypothesis of how this all works, based on how I've seen these things used in the past, and based on how this would make sense as a way to organize things. So if I build WinMain first, and then I include here win32 main.lib, what happens? Now it builds correctly, okay? So if I build the exe first, and then I include the .lib here, then this can work. And what happens if I run winmain now? win32 main. There you go, 0, 1, 2. Easy, right? There's only one big problem with doing it this way, which is if you do it this way, it doesn't really work for a plugin system, right? Because I had to know about this module in order to build this one. Now this could work if the entire base layer just got built into a separate lib file from the beginning. Like from the get-go, you had a lib file, and then all of the plugins and the exe. If the architecture is that, if you built it this way, the architecture would have to be that the shared thing gets built first into a DLL, and that the lib then gets statically linked into all the things that are going to depend on it. And you would have to be confident that the plugins will continue to find the DLL in the correct path. And that makes me nervous. What if that doesn't stay true? How do you keep that true? How do you keep the DLL in the correct path? Because let me show you what I'm afraid would happen. I built win32 main. Let's open up this folder real quick. win32 main.exe is exporting the symbol, and win32 main.lib is telling the other DLLs how to find the symbol, right? So it contains the symbol, but it does not contain the information about how to find it statically, right? In order to find it statically, we build this, right? And now when I build the DLL, I can tell the DLL, hey, here's a symbol. In order to resolve this symbol statically, I've got a little lib for you, and that lib contains the logic of how to convert this sort of static symbol into something that links up dynamically, right? Links up at load time. But it has to link at load time now. That's the trick. If win32 main exe went and lived somewhere else, and let's do it this way. So this is now going to look for its library in .. slash, so it'll find it. Let's rebuild. Good. And then we take win32 main exe and we say, okay, win32 main exe lives over here. But this main exe is set up to look for the DLL one path back. So we built, imagine this, we're building our program, our main program, and then we're packaging it up. So we send it all to our build directory, and then we rearrange everything afterwards. We say, once we've constructed the executable, we rearrange it and some other files to create the package that we actually want to send to the end user. And so it's been moved, and then they install it in whatever path on their machine they want, right? And then they get plugins from somewhere else and put those wherever they want. And then they create it. We have a dialog in the exe so they can find the DLL that contains the plugin. Right? So in this case, the dialog is replaced with I just hard code in the path to the plugin. But okay, so that works. That's a little bit surprising and makes this more interesting. How could it be that that works? It found the exe somehow. Or it knows that the exe is already loaded. Maybe it recognizes that the exe module is the correct one even if you relocate it. Okay, so what I'm going to do is I'm again going to specify this path literally. This time I'm going to give it the full path. We're going to say you go in and you look for Mr. Forth research. Let's see, what is it? Mr. Forth research Lincoln load DLL. And we're going to go on a journey. Let's take the exe out of this path. I've got this Scratch folder over here. Let's drop it right here. Let's move over to Scratch exe. One thing I forgot to do is let's rebuild. Okay, so in Lincoln load we have Win32 main. Cut that. Paste it into Scratch. So the exe exists here in Scratch exe. It does not exist at all in Lincoln load. There's no Win32 main exe. In fact, besides let's just get rid of all of it, right? If we dropped all of the build artifacts for Win32 main, and we have it way over here in the middle of nowhere, and then we run Win32 main, it still works. Interesting. Okay, let's take some notes. So when we are in Win32 land, decal spec DLL import land, have to link to a .lib with the from the corresponding decal spec DLL export. Case export in exe, import in DLL. I find the exe can be moved anywhere, and the DLL can be loaded at runtime, right? So this right here is runtime linkage. We're reading in the DLL at runtime, and it's still able to figure out where the symbol is, even if I move the exe completely. So the path seems to not matter. The path of the exe seems to not matter. It recognizes that it's the correct exe, that the one that's already loaded is the correct one, and uses it correctly. That's interesting. That makes this maybe more viable than I was expecting. Manually managed runtime linking might not be better than this. Let's try a couple other cases, because while this works, it might not be the best option. It might not be a good idea for my base layer shared stuff to go into a .lib that's tied to a specific exe. And the reason that might not be good is, say I've got this base layer, and say I have a text editor and a video editor that are two separate programs that are both EXEs with their own plugin systems. If they both have their own copy of the base layer, and then the plugins that exist want to sort of have the same format for some reason. If I want a universe where the plugins to one are actually plugins to both somehow, and they provide different functionalities or something, or they provide cross functionalities, I would have a problem, which is that they would only want, like, dynamically, they would only ever be linking to one copy, but statically, how would I know which lib to use? Would I use Mr. Forth editor.lib or Mr. Forth video or Mr. Forth text.lib or Mr. Forth video.lib? Each of them would contain the symbols for the base layer, but only one of them could be chosen statically, and then it could only recognize one or the other, right? So while it's nice to be able to export from exe, let's see what happens if I try to export from DLL and use the stuff in the exe. So for that case, let's say it's in a DLL, and so actually single X is a DLL side feature, right? Single print and inc is a DLL side feature. And let's say I'm still going to dynamically bring in lib begin, but I want single print and inc to be automatic, right? This is like, we're pretending this is a part of a base layer. And if I really had a base layer, it would stand by itself. It wouldn't get mixed in with some other library stuff. But if this is base layer, then this becomes DLL import on this side. And now what happens? I wonder. Well, this can't possibly work because you see the problem? This is getting called before I load the library in. If this was going to happen, I wouldn't be able to runtime load the library anymore. You see what I mean? Like, this runtime loading of the library means that this symbol can't be resolved when the program is loaded. It would, if I want it to be resolved at runtime like this, I don't think DLL import would work. So yeah, let's see that. First of all, yeah, this flips the order around on us. So now it's win32 library.lib that needs to get linked into win32 main. And that links. Now what's actually going to happen here is since I linked it in, it is going to link it in statically. So this, it couldn't be a plugin, right? So that's the trick. If I put it in a DLL, it can't go in the plugin DLL. It would have to be in a sort of runtime, Mr. Forth base / runtime DLL, right? And then this here should, let's keep the structure we had going. So this gets transplanted over to here. I bet you this doesn't work. And the reason I bet you that is that that exe, it has the full path to Win32 library DLL baked in right here for the runtime load. But I bet you for the .lib that we baked in statically, now I bet that the relocation of the exe might be a problem. It might be. Actually, it might be fine. It might still use the full path to this DLL. So let's try it and see what happens. We're here. The code execution cannot proceed because Win32 library DLL was not found. Reinstalling the program may fix this problem. Okay, so there we go. That didn't work. If I build and then I go back to Mr. Forth research link and load, and then I run Win32 main, that works. So this works if the DLL it's looking for is in the same path. Is that it? Because I didn't move the DLL at all. Right? So it's not that I couldn't find the DLL at, like, even when I moved the exe, it couldn't find the DLL. So it feels like it wants the DLL and the exe to live next to each other for this to work. Or it wants the DLL it's probably using the default search path for the Win32 library.dll. So it's looking in the system folder and then in the local folder and all that stuff, right? We could look that up. The Win32 DLL search order. Okay, unpackaged apps is probably what we're talking about. DLL redirection. API says. I don't know what these are references to. Eventually it does get to searching inside the current directory. I don't remember this list being so complicated. They must have made the list harder to understand. Let me read a little bit more carefully. Here are some dynamic. When a packaged app, when we say packaged app, are we talking about something with like a manifest, or are we talking about like UWP? Multiple versions of the same DLL to exist in different file system locations within the same operating system. You can control the location from which the DLL is loaded by specifying a full path. If you don't use that method, then the system searches for the DLL at load time as described in this topic. The DLL loader is part of the operating system. Here are Cool, Terrius Python. Yeah, I'll probably be going for a few hours. I still got to get to the Linux side of this. But yeah, see ya. I don't know what a packaged app is, according to like it's referencing this idea of packaged app, but I don't know what that's a reference to. Anyway, I think that the reason it's able to find the DLL here is because it's in the same path as the EXE. And so one option here would be that, which is you build the, you ship Mr. Forth EXE program that supports plugins along with the Mr. Forth base DLL. And so that can just automatically load time depend on the DLL, and then all the plugins will inherit that without needing it to be in the same path. Hey, Batman. Welcome. Nice name. That's the same. I use the name Batman whenever I'm playing like a classic roguelike. If you played like NetHack or Dungeon Crawl, I always like to be like, who are you? I'm like, Batman. Thanks for the compliments. It's appreciated. So let's write down that as an option in the notes. So this is when we export in DLL, import in EXE. The EXE can only load if the DLL is immediately found in the DLL search path. They can move together. So yeah, let's double check that, what I just said. I think that's true. So if I take both of these and I move them over to Scratch, I think then oh, it kind of failed. That must be because this failed, right? Let's just take that. Let's just take that and replace it with this. And then let's take both of them again out of this path and into this path. And boom. Okay, so that works. So you can move them together. I would assume I could also do something like if I was willing to put this DLL inside one of the system paths, I'd be pretty reluctant to do something like that. Like if we go back to that thing about the standard search paths we were just looking at. Oops, not this. You don't need to see the Twitch dashboard. You need to see this. I don't know what DLL redirection means. Okay. Man, oh man, they really made this complicated since the last time I looked at it. This is all new. So this is not new. This is some old complicated stuff. Formentora8 asks, would this case be similar to like loading OpenGL functions where the exe is built and the exe imports the symbols? I'm sorry, that one of the words for some reason got censored and I don't know why. Built with star star star, and the exe imports the symbols with get proc address. So yeah, that would be different. I'm doing the DLL import route right now. I'm testing that out. What you're talking about is what I would call manually managed runtime linking. That's like this thing here. Get proc is my macro that wraps get proc address. So here I'm loading a DLL and manually pulling out the names. The upside to doing it that way is that you can sort of build it yourself. You can tell it where to find the DLL. You can have backup options. You don't have to just crash and burn if the thing you're looking for isn't found. But the downside to it is that instead of just writing, so normally when you write a function, you write the symbol like this, right? You just write the name of the symbol, and as long as it links, you can call it, right? You write the name of a function symbol, you call it, and then you make sure that it links as a final step. If you do the other option, what I would have to do instead, right, is I'd have to go, okay, this becomes a function pointer that is initially 0, right? So the syntax changes that like that. And then here you have to go like, okay, load the thing before you ever call it. Make sure you load that first. And make sure for everything in every single function in the library gets a, something like a get proc kind of deal. So you got to make sure every single one of these undergoes runtime linking. And none of this is automated for you by the language, unfortunately, right? So now it means that if you had written a header, right, if you have a header with a base layer in it and you declare a bunch of functions, how do you transform that into this and this automatically? Yeah, it's unfortunate. Now, the answer might be to say like, hey, you're gonna have to use meta programming or something, right? Like you're gonna have to go through here and be like, this is a Mr. Forth shared function, and you're gonna have a thing that scans for all the cases of Mr. Forth shared, finds them, and then generates this and this as like an X list or something. Or we could even go to that point. We could say like, hey, you're just gonna have to specify the entire Mr. Forth API as an X list like this, right? You'll make a separate header file, and you'll just go X single print and inc, and then you'll have X double print and deck or whatever, whatever goofy API ideas you need. You could do whatever you want, and then you could use the X list to generate the version that's dynamically linkable, which is different. You still need something that looks like this for the version that defines the functions and exports them, right? So you would still want the like decal spec DLL export as a function symbol, not as a pointer and a load, but as a symbol and then a definition, right? So you'd have to be able to generate all of those from the X list, which you can do. The only downside to that, right? The only downside to doing it that way, that solves the problem on many fronts, but it then fails the problem on one front, which is that if I write it this way, then I can give you a header that looks like a bunch of functions that look like this, right? I can give you a header filled with functions that look like this and tell you this gives you the basic function prototypes. If I do the X list, I can't give you that, because that header, the list of the nice function prototypes, would be one of the things that gets generated from the X list. Instead, I would have to say, hey, in order to read the API doc, like the API spec, you got to read it through this X list. Maybe not the worst thing ever, but it's a big step down in how nice it is for the human to interface with it, right? So because we're dealing with text files, that would get in the way. Now, another thing I could do is say, hey, it won't be an X list, it'll be a meta program. I'll just say like, make it like a comma separated value kind of thing, and then generate the text files for all of these. That would get closer to the right thing, but generated text files are still a step down. Like if I want to manually manage, like, here are the things dealing with single, and here are the things dealing with double, right? And I want nice comments and space it out and little notes like ink can roll over at U32 max or whatever, right? If I want notes, it starts to become a pain in the butt then to transfer from this text file to this thing with all of the nice notes. It's like I can't just write the artifact that the human will read. I, as the human who writes the code, kind of want my interface for writing the code to match your interface for reading the code, so that I don't have to do a mental projection, so that I don't have to do an extra mental projection, right? So it would be very nice if there was a way to avoid having to do dynamic linking, and that's why I'm spending so much time. I know we can make this work. The question is, how good can that work? And I'm kind of pretty familiar with the limits of that, and I just kind of gave you the different varieties of how that degrades the human interface to the code. But it does improve the computer interface to the code. And the only way to fix that would go all the way is to write a language that takes that part seriously. So I'm focusing on this because if this option and this option can be made to work well enough, it does come with some pretty big advantages in terms of how you can maintain the code in the long run. I have another question or another comment. I think Starfreak Clone says, I think you almost always want to stick to app local though. It's simple and easy to package. I'm not entirely sure I know what you mean, but I think you're talking about the DLL thing. And I agree. I definitely want the I think that that's the right thing to do, is to just say let the DLL live with the app. The only reason, and I don't know if you saw this part, the only reason we're talking about splitting the DLL out in any at all is so that plugins can be written in such a way that they don't care about which exe is loading them, in case I want that kind of freedom. Right, I might want to write a DLL that acts as a plugin and have that DLL say, I depend on Mr. Forth base functionality, but I don't want to have to link specifically to this exe or that exe. I just want to tell you that I depend on the DLL. Yeah, exactly. Something like hot reloading or a plugin system require this split so that there's a DLL. And once you have a DLL and an exe, if you have a base layer that is across both of them, you want some structures to be shared across that split. And that's the tricky bit we're working on, figuring out the best way to organize that. But I definitely don't want I don't want to have a thing where you're like, okay, first install your Mr. Forth base runtime into the system path so that all the Mr. Forth applications will find the base layer. That's just, that's like the C runtime. I don't know if anyone's familiar with like the mess where you have C++ DLLs missing, like the VC runtime DLL is missing on this, install this to run. Like you build an application in Visual Studio, you give it to your friend, and it turns out they've never installed Visual Studio, and so it doesn't run on their computer unless you also find the DLL they need and send that with it. I don't want to build that same disaster. So probably I would say the right thing to do is, if I was going to split the base layer out into its own DLL, which is what this part is about, then it would run in its own DLL that lives side by side with each exe. So there would be a separate copy of the DLL for every exe that uses it. And that way the exe can just say, like, look, you're supposed to have the DLL right next to me. That's how these get packaged and moved around always. It's part of how it's expected to work. And if it's missing, then fix that. That's all you need to do. So one thing I didn't consider that is possible is we could do manually managed runtime. I'm going to do the DLL to DLL option next. We did exe to DLL, DLL to exe. I want to look at DLL to DLL still. One thing we could do is the base layer could be an exe, and then the difference between the text editor and the video editor, if that's the example we're running with, could be that those both live in DLLs. This would be more similar to Casey's Handmade Hero setup, where the base layer or the exe loads in the main program through a DLL. And so then you could hot load your program through something like this. And a plugin system would be further DLLs on top of that. And then they could all share stuff that is provided by a single Mr. Forth base exe. And then if you're running the text editor, Mr. Forth base exe just gets parameterized with the text editor DLL. And if you're running the video editor, Mr. Forth base exe gets parameterized with the video editor DLL. The only problem with those kinds of solutions is that running the exe is a little bit more cumbersome from the command line. But if you package it up with like a shortcut that is set up to automatically have the command there for you, and you put a separate copy of the exe in each of the installs, that could be okay. And it would enable hot reloading more easily from the ground up. So it's a thing to think about. Okay, so another idea here is, if it was going to be manually managed runtime linking, it could be that I write something like this, and then I have a parser, right? I could just say, hey, we're going to have to bite the bullet and write a little bit of C parsing, find the Mr. Forth shared macros, read the function signature that comes after those, and that function signature, save it into some metadata, and use that metadata to generate one of these. Hey, Brett. Good luck with your errands. DQFFT, yeah, this is in the annoying Windows vein. Um, I would say that the avoiding Windows thread blocking on resize is an extremely annoying problem. That's real hard. That's like the that problem arises from some stuff that's built way into Windows and like the way the Windows compositor works. It's solvable, but man, they sure did a number on making that tricky. This is also annoying, but I think this is annoying on Linux too. Like, I think this isn't something that people didn't. Um, we just we haven't restarted the operating system project since the days when before we really knew how important modularity was gonna be. Um, so this is, and also like our programming languages don't help with this as much as they could. So it's not all on Windows. Like you could say like, hey, this is because your language didn't give you a better way. Like C doesn't get involved in the business of making sure that data which is living in a DLL, it can be shared to EXEs, because C likes to pretend like EXEs and DLLs and shared objects. That's not, the language doesn't know anything about that. And so it's all custom, it's all built as like custom language extensions instead of as just a core feature that the language is like, oh yeah, you want to runtime load in another module? Here's how that works, which would be nice to have. I don't know. Do modern languages have a better story about how they can help you with this? Like, I don't know if JAI or Zig or Odin have a thing where I could say, hey, scan all of these functions and treat them as symbols that are callable, that are going to be null or an error until I runtime link something in and automatically do the patching then. I don't know if that's something a language can do or has done. Something I should talk to some programming language developers about. Okay. So let's talk about the DLL to DLL case. So the annoying thing about the DLL to DLL case is that it doesn't fit in with a test that I've built so far. I've got main, I've got library. Let's take some steps back. So library is going to live over here doing DLL import on this. We're going to have win32, let's call this base.c. This is also going to be a library, but it's going to now become the library that provides the actual symbol definition for this guy, right? And then what we're saying is both of these, the exe and the library, are simultaneously depending on a DLL that contains the shared win32 base.lib, win32 base.lib, this will be win32 base.c. So we build the base.c as a DLL, then we link that in for load time linking, right? So these .libs go in statically, but what these libs actually do, again, is set up the symbols for these DLL imports so that load time linking can work. So does that build? Base library win32 main. Win32, oh, we're in the wrong folder. Let's go over to Mr. Forth research link and load. Win32 main 012. So that works. And now the print and ink is happening here in base.c, and library and win32 main are both finding it. Now base.c has to stay with win32.exe, but presumably there'd be no problem at all with relocating this. If I did Mr. Forth research link load, and I built that, and then if I took main exe and library DLL, and I moved them over to Scratch exe, and then I moved this over to Scratch exe, then oh, whoops, I don't want the library DLL. Let me rebuild this. And I want base and I want main to come with me. I want library DLL to stay here. And then I put those there. Then I run this. Yes, that works. Okay, so what we're seeing is if I want a DLL import, there are basically two main cases where that works. The DLLs can move. Well, let's say this. If the import DLL is already loaded before the, or if the exporting DLL, the base layer, is already loaded before the importing DLL, this works no matter what. Well, let's test one thing. So I'm currently DLL importing these. Let's say I switch this over to being a function pointer, and then I load library, so we'll call this the base, and we want single print and inc. And this comes from Win32 base DLL, and that goes into single print and inc. So single print and inc here gets loaded from the base, and then we can call it, but I've loaded it in dynamically now. So there's no static dependency on Win32 base, right? Win32 base needs to be visible at runtime for the exe to work, but it needs to be visible statically, right? Or not statically, but it's like it's set up for load time linking on the other DLL. What does that do? So they all built successfully, and presumably, well, let's see. So they run just fine here. If I move this and this over to Scratch and run it again, yes. Okay, so that works. So what that means is the exe can actually dynamically load the base however it wants. And then once it's loaded into the process, this one will find it, even if its path has changed. So let's do one other trick. Let's say this is gonna go in Scratch exe. So we're gonna load the base DLL explicitly from Scratch exe, and we're gonna move, well, hold on, let's delete everything, build again. Actually, I'm gonna clean, I'm gonna Forth research, link and load, build, clean, build. All right. Undefined BH. Heyo. Today we are working on researching, investigating how on Windows, and then in a minute we'll do this on Linux too. Well, specifically on Ubuntu. But I think it's the same for all Linux kernels mostly, or all Linux distros mostly. But how when you have your program split up into executable and a DLL, or an executable and multiple DLLs, you know, for things like hot reloading or plugin systems, if they have some shared base layer, because, you know, I'm a big on having a base layer. if I've got my base layer and it's got something like a single unified data structure like a log stream or some Scratch arenas, how do I make sure that they are the same log stream and the same Scratch arena across the entire process? That's what we're working on, even if it's split up into EXEs and DLLs. And if those EXEs and DLLs all rely on the base layer code, how do I make them link in to exactly one runtime data structure? That's what we're working on. MD Subuntu, you mean the single space indentation? That's actually my virtual whitespace. I don't know if you've seen my virtual whitespace before. So if I turn on in my editor, show whitespace, so now it's highlighting all the spots where a whitespace character appears. You can see I actually use two space indentation in the text file, right? But what happens, right, is if I turn on my virtual whitespace, it hides the whitespace at the beginning of each line and does sort of automatic layouting. And when it does that, I have it set to go down to one space. Why I have it set up so that it's two in the text and one visually at this point, I don't remember. Maybe I'm at a point where I just like one and I should do one everywhere. For a while, what was happening was I would use virtual whitespace to make it visually one because that's what I like. And I would make it 2 or 4 in the text to match with code-based standards that I was interacting with. Or I could do tabs too, right? This is all my code, so I don't know why I don't just make the text and the virtual whitespace match at this point. But that's the whole story. But yeah, I like to keep tiny little indents, fit as much on screen as possible. Okay. Where was I? I was, okay, right, so let's build this. Now the experiment is, I want this and I want this side by side. So if the EXE and the base DLL is going to go and live over here, let's have the EXE go and live in another separate folder, EXE2. So the EXE has a hard-coded path to find this DLL and a hard-coded path to find this DLL. So the question is, yeah, that works. Okay, so what that confirms is that no matter where I move the base DLL to, once it's loaded, other things that have dependencies on it work. Even if it's not in a path where that DLL, so this Win32 library DLL would never have found Win32 base DLL. We're not running inside this path. We didn't build it into this path in the first place. It's not relative to this path. There's no relationship. But since I've got the EXE itself, Win32 main is finding the Win32 base DLL in its own way. Once that DLL is loaded in to the process, everything else that needs it just finds it living there in the already loaded process. Okay. So that pretty much settles all the questions I have about DeclSpec and these different combinations. So I don't really want to go and do the manually managed runtime linking because it would just be a bunch of typing at this point. The interesting question about manually managed runtime linking is how good can it be? And I think the best it can get to is if I had a syntax like this, right? And then from that I could generate the pointers and the get procs. Or even more simple, if from this I could generate the X list that I could then use to do the rest of this. Oh, this would need a void. Then it would be good. I could also manually maintain the X list in parallel to the header, so I wouldn't even need a generator. Instead, I would just go like you'd have your header, and then you'd go, okay, let's start transforming this. So X, boom, and then you do that again for each thing in the header. And as long as I maintain the X list of the API to match the header of the API, then you could manually do the linking. I think that would be the simplest way. It doesn't require any parsers. The way it can get busted is if they get out of sync. There are ways you can make an automated test without having to write a parser. So for instance, I could Formenter A, yeah, thanks for the notes. Yeah, I think that so there's all these different options, and a part of the question here is like, how do you not lose your head trying to think through pros and cons along the way? The simplest way to think about it is that the base layer is built into the application. It's not optional, right? It's the base layer. The exe itself is definitely using it. So if it lives in a separate DLL that the exe depends on, that feels kind of silly. Flipping it around actually makes more sense. Put the application-specific stuff in the DLL, and the exe contains the base layer. And the reason that makes a certain kind of sense is the base layer is not the part that's most valuable to hot reload. It's the application-specific stuff that's most valuable to hot reload. I mean, it'd be even better if you could hot reload both. And then what you would need is an exe that can load in the base layer as a DLL and the main application layer as a DLL, and all the plugins to DLLs. The problem there is if you're doing it for hot reloading, you need runtime linking. So it becomes this DeclSpec import thing. Really, what it means is this is just about as good as statically linking, right? It's almost that good. The only difference is that if it's statically linked, then you can't have like plugins or hot reloading in a separate module somewhere at all, right? If it's truly statically linked, then you have the problem of there are two separate instances of the data structure. This solves the problem so that there aren't two separate instances of the data structure. But besides that, it's as good as if it was statically linked. So if you want something like hot reloading, where the DLL contains the main application stuff, then you would want to start doing something at least like this. But if you go to manually managed runtime linking, right, where you load library A and get proc address, then you can do even more. But if you have big fat, and keep in mind, my base layer has like something like 30 or 40 or 50 functions in it, so it starts to be a bit much. I don't change the base layer that often, but if they're, yeah, I don't think hot. You know what? It's tempting to say like, hey, let's make everything hot reloadable. The base layer, the application layer, and all the plugins. Let's make sure that everything could potentially be hot reloaded in this architecture. And in order to get there, they would all want to go into DLLs. They would all want to go into separate DLLs. Okay, so there is a couple things we can say. Let me take us some steps back. You kind of want to avoid coupling the implementation of your base layer stuff with stuff that's like application specific or plugin specific, because say I've got a text editor and a video editor as my two big projects. Let's say that's the scenario, and they both use base layer stuff. But then I have some DLLs that are like cool libraries that kind of can play a role in both, or I have a plugin that acts as a bridge between the two somehow. And so it wants to plug into both as a single DLL. That's where you get the situation where if you've coupled the base layer stuff in to either one of them, then you can't build that thing that could participate in both. Now that's some pretty abstract thinking from one perspective. And it's like, are we over engineering for ridiculous future states? But I don't think so. I think it's manageable to actually say, what if the base layer lives in it on its own module that is separated from all of its usages, right? That seems reasonable. The harder thing to do then is if you make that decision and you lock that in, the base layer is not coupled in with anything else. Another reason, here's another justification for that just occurred to me. Say I've got these two big projects, a text editor and a video editor, but I have some other smaller projects. Like I write up, I've got my audio visualizer for my podcast, or little toy programs that I write from time to time, and I want them to run on my base layer. Well, right now I just run them on my base layer by compiling the base layer into them, and that could keep happening, right? I just statically build the base layer into my toy programs. But if those get big enough to the point where it makes sense to say like, oh, I want hot reloading on this little toy program now, or hot reloading just makes sense for this toy for whatever reason, then it too starts wanting to say like, hey, how do I get the hot reloading? And if the hot reloading is coupled in with the text editor version, it's like I've got my base layer plus text editor exe, I don't necessarily want to have too much stuff that's like core features of the architecture bundled together like that. I tend to write lots of small toy programs and want features that are in the base layer for one part of my code base to apply everywhere. So let's just set aside whether or not it's justified. So let's say the base layer wants to be isolated, and take that as if it were justified, and think through the other things that are implied that could go right or wrong from there. The next thing is you don't want a situation where that lives off in some alternative path that is shared across all things ever, right? If I'm a user of my own products and I get into a situation where I have to install the DLL path, the base layer runtime thing, before any of my programs or games will work, that's kind of annoying, right? So we definitely don't want the thing where like there's a standard system path for this thing. The DLL should just go with all the EXEs, but that seems easy enough. And you could be concerned about the duplication, right? Like, oh, isn't this a waste that there are duplicates everywhere? That doesn't seem as bad to me. I mean, the ultimate version of fixing that problem is to move it all into the EXE. So the EXE contains this ability to be the base layer, and then all the applications are like DLLs that run inside that. And so then you have sort of like a mini application loader for a special kind of Mr. Forth flavored application. And then you run that exe and it says, hey, what DLL should I use to turn this into a full application? And you pick one of them, the video editor or the text editor or the toy program or the game or whatever. I don't love that. That's not really the direction. I'm not looking to build a whole runtime platform kind of thing with like, you know, the ability to run different things on top of it. And quite honestly, like if I was building it statically, I would never mind the fact that it's duplicated code. It's not like it's a huge piece. It's not like we're talking about the Chromium duplication or something, right? duplication hurts more the fatter a thing is. So I think it lives in its own DLL. Here, I'm going to start just pitching ideas until I hit a problem, and then maybe I'll backtrack. But it lives in its own DLL. It lives in a separate the DLL is, there's a separate copy of the DLL for each shipped package. So it's not like there's a single shared universe with one copy of this DLL. It's just that it is separated out as a separate thing from the exe. That the reason I like that is so that if I want to do something like, hey, run the text editor is just an exe you double click on and it works. You don't have to go make a shortcut that bundles them, or a script that bundles them, or something. The correct way to launch the text editor. The text editor should just be an exe. It should be a point you can say, like, run that executable. The executable needs to live side by side with the DLL for the base layer. And if the text editor wants hot reloading for text editor core features, then that exe is hard coded to find a text editor DLL that it can hot reload. But that's not built into the base layer, and the base layer is not built into the exe. Because it's not trying to be generic, right? The exe is still the entry point for the text editor. It's just that the base layer is living in a separate DLL. I think that makes sense. And if I look here, the export is in the DLL. Exe can only load if the DLL is immediately found. So this is the one downside that we found to that. So all the nice things about that are it's not coupled in with the text editor features. It's not... it doesn't have to be like on its own system path or something. It can just live side by side with the exe, but it has to be side by side with the exe. If you try to copy paste the exe somewhere else, it'll stop working. But that's fine. Usually you don't expect that if I give you a bundle with an exe and several DLLs that you can rearrange those and that they still work. Let's see. I got a comment from Raven CGG. You could export one function from the DLL that is then called by the exe to retrieve a struct filled with function pointers from the DLL. This is how Quake 3 did it. Then you aren't doing get proc address more than once. It's much simpler. Yeah, so I'm familiar with that technique, and that's a way to do it. That does not solve the problem at the level of how much code you have to write. So the difference, that's nice if you don't want to do get proc address over and over again, which is probably a good thing to avoid. But even if you do that, right, the problem is what you want is to just say, hey, this function exists. Like, you just want to declare the function and be done. It's not that big a deal, but you can also say, like, I'll declare the function and also mark it as shared so that it knows, like, sometimes shared becomes the thing that says, oh, this symbol is defined here and we export it, and other times it becomes this symbol is usable from here, but it's defined elsewhere and needs to be resolved. That's all nice. Once you have something like a struct, then you have to specify your API like this, like base API or something like that. And then you go like, okay, base API is going to be void single print and inc void, and then you have like your shared is API init base API. Right. So you can do this sort of thing, and then you would just load in API init somehow. You wouldn't even, you'd still if0 that out actually, because what you would do is you'd say like on this side API init's a function pointer, and then API init, you fill in the global base API, right? You can do this, and then you have base API is visible to the exe, and you allocate that or something, and then you fill it right here, and then you're good to go. You only get proc address once. But what you haven't done is you haven't avoided the thing where you have to list out the API more than once, because now when we go to implement API init, we still have to do something like, okay, time to implement API init. What do we do? Oh, well, we're going to do API single print and inc equals single print and inc. So now it's just as good as if I had to do the xlist version, right? Once I have to do the xlist version one way or the other, this is just like runtime efficiency trade-offs. But the architectural question of, do I get to specify it just once, or do I have to specify it in multiple places? You've already lost on that front, whether or not you do it through a struct or through like a list of manually loaded get proc calls or whatever else, right? There's no getting around the fact that if you start doing manually loaded runtime loaded DLLs, that this happens. Now, there is something else to consider. This is worth considering. So after saying all that, what I do realize is that if I ever want hot reloading to be possible, anything that's going to be hot reloaded has to be runtime loaded, right? This is required for hot reloading. I can't do declspec DLL import if I want hot reloading, because there's nothing to unload. There's no way to repatch the linking every time that the DLL changes. So if you wanted something like the Handmade Hero hot reloading style feature, you can't avoid doing it this way. Right? But yeah, we've looked at all these options. So I think we're done with this part. We might want to try to do the same thing on Linux next. See what the options, how they work there. The other thing I don't love about this, I just want to say, the other thing I don't love about this is I don't want to have to change all of the occurrences of my base API to going like this. I don't want to have to do this everywhere. It's another reason why I don't love doing the struct thing. You can have another step. It's like, okay, you use this to load in the function pointers, and like this is like API load, and then there's like API init, which takes those and writes them out to global function pointers, and then the global function pointers go like that. Right? But one way or another, you end up, if you want the API to look pretty like this, then you end up in a spot where it has to be global function pointers. It can't be in a struct. Or it can't be in a struct as its only way of existing, right? It can be in a struct for passing it around, but at some point it has to get unloaded into global function pointers, like what you would do in an OpenGL loader. So I'm thinking, yeah, and there's the other funny part of this is like, do you really expect to hot reload the base layer for real? Because a bug in the base layer just might not be I don't think hot reloading really is for that kind of change. Most changes in the base layer are like, oh, I want a new helper function, or oh, I had a typo here that's affected a bunch of stuff. I guess that typo case is where it could be nice for something like edit and continue, but I don't really think of hot reloading as being so much about bug fixing as you're running, as much as I think about it as like tweaking the way a thing works while it's running. Patrick OMG, I don't know what you mean about like what's the it saves the path thing you're talking about. Like what path are you talking about, and why would I? How does that relate in? Like, could you say a little more? Um, I might be missing the point you're going for. But it feels to me like whatever way I look at this, well, let me run this experiment. If it's in a DLL, it could just go through decal spec import if I give up on hot reloading the DLL of the base layer. And maybe that is frustrating, but I think hot reloading the base layer is rather outside of the use case for hot reloading that I usually picture. I mean, I don't even do like DLL level hot reloading at all, honestly. It's been a long time since I've set up a system that can do that. And where I do sort of think it would be valuable is in things like if you have plugins that if you're developing plugins for a text editor, for instance, or a customization layer for a text editor, at that layer being able to unload and reload your work is very nice. But at that point, you still wouldn't want to be changing the base layer. On the flip side, if I build my system, right, if I have Mr. Forth shared and I have the list of API bits, and they're all using the decal spec import approach, and then I try to go use the same system for something that's hot reloaded, it wouldn't work then, right? It would then start to break down. And so this is the other thing. Formentera was asking about the build is a little more annoying. So the thing that's slightly more annoying about the decal spec import is you have to have these lib files. So if I tell you to write me a plugin for my text editor, and the way that plugins work is you have to link to this library that sets up the load time dependency on the DLL. Then I have to make sure to provide you a .lib somehow. And that you can include in your build line. And that .lib has to match. It has to be a match for the version of the exe you're running, or rather the version of the base layer that your exe is running on. And that's where you get into annoying things like, okay, if is there a debug and build and release mode of the base layer so that you can see in the base layer in your debugger? Really, what this all comes down to is it would be nice if this syntax could be automated through runtime linking. It should be possible. And it isn't supported in C. And so I have to pick one or the other poison. The one poison being that you can't hot reload, and that you have to do this like static linking thing. You have to provide the lib that provides the instructions for how to link how to link at load time. That's one poison, and the other poison is that you have to build an X list in parallel to your APIs and keep them in sync manually or with a script or something, so that you can use the XList to automate the reload process that happens, like with the get proc address. So which poison is worse? The poison of not having hot reloading and having the builds be annoying on this side, or the poison of the API author having to maintain two copies of the function list? So Patrick, let me explain to you what the main problem is. So the root problem here is just you have various reasons for why you want to split programs up into an exe and a DLL, or an exe and multiple DLLs. That can include things like hot reloading. It can also include things like plugin systems. But one way or another, you get into situations where it is nice to have that split be possible. And once you have a base layer that has certain global data structures, like a log data stream or a memory pool that you want to treat like a global, then when you have that split between exe and DLL, you don't want each exe and DLL to have a separate copy of those global data structures. And so it becomes necessary, if you're having a base layer with cool features like logs and scratch memory, and a base layer that is compatible with something like hot reloading or plugin systems, dynamic code logic. It's nice to have a solution for that that's possible. I don't want my base layer to preclude these rather fundamentally important programming structures. And so I'm trying to find the best way to do it. And one option I'm looking at gets me halfway there. It gets me plugins. Well, I guess plugins and... Yeah, really, ultimately, if it doesn't support hot reloading, it doesn't support plugins. Because plugins, you want to be able to load a plugin in at runtime. You want to be able to load them and unload them and reload them. And you want to be able to have an unbounded number of them. So plugins are really not different in terms of fundamental structure from hot reloading. So I guess I want to take hot reloading as the project, because if I can't do hot reloading, then like hot reloading is the nearer, harder version of plugins. If you can support hot reloading, you can support plugins. But if you can't support hot reloading, then whether or not you can support plugins is... Hot reloading is just the harder version, right? They both share some things in common, and hot reloading requires even more. So saying hot reloading is the goal is a good way to snap into view what I need to think about. So DeclSpec import is out of the question because it doesn't support hot reloading. Period. We're done with that series of consideration. So, conclusion. DeclSpec DLL import does not support hot reloading or plugin architectures. Well, that's not quite true. If I have a plugin, I can runtime load in the plugin, and the plugin could depend on the base layer through DeclSpec import. That's true. The issue is if I have a system that only applies to base layer stuff, but doesn't apply to plugin, like the dynamic linking of plugins and hot reloaded layers, is that okay? Do I want... DLL export does not work for symbols that come in through hot reloading or plugin architectures. So if I use this, it would only work for some functions and would create another variant of linking. Therefore, I'm going to say I don't want that. I'm going to treat everything as if it could be hot reloadable so that they all go through a similar pattern. Okay, so we're gonna go with that conclusion. Starfree Clone says DeckelSpec import has odd behavior when interacting with inline and ComDat functions. That's good to know. Yeah, I'm kind of skeptical of DLL import. I came in skeptical. It turns out that it works better than I expected, but I still think ultimately its primary downside is that it's a little bit magic and outside of my control. And so if it doesn't happen to do what's useful for me, I end up having to do something else anyways. And there are cases where it doesn't do what's useful, right? There are just cases where it's not good enough. And so using it in some places where it works is kind of like just saying you want more ways that things can, you want things, in a good system, and like when you're building a big architecture, decreasing the variation helps you to manage the complexity of what things can go wrong. If things can go wrong in two different styles of way, that is more cognitive load, that is more maintenance load. If everything that can go wrong only goes wrong through the same channel, that at least lets you simplify the mental model. Doesn't mean things won't go wrong. It's just less variation of how things will go wrong. And so there's also less keywords flying around, less patterns of how you structure things. So I'm thinking if DLL import is insufficient in the cases I've already thought of, and it's insufficient in more cases that you're aware of, it's just more proof that it would break down sometimes and cause other weird behavior. And this puts more stuff under my control. The downside is it's going to increase the maintenance on me, the API creator, for certain things. But it doesn't increase the maintenance at all for it doesn't increase the maintenance burden at all for someone who is a plugin writer, which is what I care about, right? Like I would like the plugin writer or the customization layer writer or the person writing the hot reloadable code to not. I would like them to not have to take on some extra burden. And while it's a small extra burden, the extra burden of linking to the correct static .lib to enable this load time linking, I just don't like it. So let's say there's no DLL imports, but I still want something like this. How do we minimize the difficulty of this now, right? So now the problem is when I load library.dll, it needs to get, here's my base layer, right? Here's our pretend base layer. Here's our pretend library. Let's call this pretend plugin layer. Over here in base.c, we have the pretend base layer implementation. That's just DLL export, because whether or not we are doing runtime linking or load time linking, the export is what we want on the export side. And then over here, let's see. Get rid of this for a minute. So this is pretend plugin layer. Get rid of these. Get rid of these. Pretend plugin loader. Pretend plugin user. Pretend base user. Pretend base loader. Right, and then we have pretend base layer needs to exist again. Pretend base layer looks like this, but the problem is this isn't what pretend base layer would actually be. Pretend base layer would actually be like this, right? And then pretend base loader would be like this or something like this. There might be a struct involved to minimize the number of get proc addresses or something if that made more sense for any reason. But all of that would probably be generated by an X list. So um, we have our pretend base layer. Now the issue is, pretend plugin layer here, do I need something like DLL main? Is that a good idea or a bad idea? That's the last question. And maybe what you need is, whenever you load in a DLL, that depends on the base layer, that DLL needs to have not a DLL main, but like a Mr. Forth main, right? Like a base layer main. So it'd be right, so these are static functions that go base load, and they do this deal. Except if we wanted to, we could say, let's actually mark these as if they're exported functions. And the reason we mark them as exported functions is here in the exe, we'll just say, hey, load the base like this. So our base layer is now coming to us dynamically, so we need a dynamic load at the beginning of the function to set up the base layer. If it's coming in, if we're a DLL, then when we load the library, we're going to have a void library base load void library base load, and then after you load the DLL, it's kind of like there's a main, because the DLLs have a DLL main, so I could just have done it there, right, run this, but a reason why I wouldn't want to do that is the Linux side doesn't have something quite equivalent to main that's as reliable as the DLL main side. Right? I know that for a fact. I know Linux shared objects, they have some ways to do entry, like onload functionality, but they're not quite as cleaned up and nice to look at. They're not. They make you more nervous to use. So manually setting up my own entry point kind of thing seems better. And so then I would have library base load. And then that would give it a chance to initialize the base layer here. Of course, it's now going to need to statically know about how to do that with the operating system. DT init. Let me take a look at that. I've looked at this before and had trouble with it. Right, so the thing I'm finding initially is like the same thing I've seen before. It's this stuff here. So there is this whole thing of you do need a way to do static initialization. And I think you could link in with that. So maybe what you're suggesting is that is more reliable. I got the impression when I looked at this a few years ago that this was sort of esoteric and not clearly within the bounds for a user to use, but maybe my impression is just wrong, and I should just use this attribute on my functions in Linux to initialize a shared object. Is that what you're suggesting? Is this something that you've seen is pretty common? Okay. Okay, gotcha. So the difference is in Windows land, the DLL main has like a more cleaned up specific time when it runs. This is guaranteed to run before anything that gets called from the shared object. But these constructors might be run in any order relative to each other. Starfleet code, I think that we're having, or Starfleet clone, we're having a miscommunication of the meaning of initialize static and dynamic here. Um, it's saying he's saying static, or they're saying static initialization in the sense of stuff that should be done before the functions start getting used. So it's called constructor because this was initially introduced specifically so that C++ constructors that are called at the global scope could go somewhere, right? But you wanted some kind of like equivalent thing for like, hey, I can't quite do this as a C++ constructor because I'm in C, but it's the same basic concept. It runs at the same time in that like soup of stuff that happens before regular execution begins. But I want to do it in a way that can't be specified either for reasons that it doesn't fit into a static like construction in a C++ constructor kind of way, or it's just I'm not in C++, but it runs at the same time, so it's for that setting up that kind of stuff. Yeah. So it's dynamic in the sense that it is not built into the binary at compile time. It happens by the loader chooses when to execute it while you're loading the library. It's dynamic in that sense. It is static in the sense that it is initialization of stuff before any data flows into the binary. Right? There's no chance to call one of the library function calls before one of these constructors go off. All the constructors are supposed to go off on load. And so they have to be written in such a way that they exist irrespective of the order to each other or their order to other functions. They should come before other functions, right? It's confusing space, right? Load time, what counts as dynamic and what counts as static at load time. It's bad terminology. It's load time initialization is what it is. Static is just a terrible word, really. Static and dynamic are relative. They're like static and dynamic are like left and right instead of west and east. Okay, so this builds. Does it run? Something crashed. Probably because I stopped putting these in a useful order. Like, let's just say they're all local. Does that help? No. What are you tripping on? Let's walk through it. Base load. Base is good. Single print and ink is good. Single print and ink works. We load this library. It's good. Library base load. Ah, there's my mistake. That should be called base load right there. That's still not good enough. Okay, okay. We get this far. This loads a function. Win32 base DLL, we get that. Single print in ink, that comes in. Lib begin, that comes in. We call lib begin. Single print in ink, that works. Okay, this looks like it's working, so why is that not working if this is working, right? If this can do that, then why can't it do it when it's... Oh, am I in the wrong path? Yeah, there's my mistake. So I want to go to Mr. Forth, research, link and load, Win32 main. There we go. Darius Python, you're back. The experiment is going pretty well. We're just about wrapped up with Windows. We didn't learn a whole lot more, but I spent a lot of time going over pros and cons of different architectures, and ultimately decided that DLL spec or Decal spec DLL import has the major problem that it's just a little bit too magic. It's a little bit out of your control how it works. And for anything like hot reloading or plugin systems, you end up needing to do runtime linking anyways. So the only time you could get away with the DLL import approach is on something like a base layer. If you were committed to not hot reloading it and to having everything in your plugin ecosystem DLL import those same things, then it would work. Then all the stuff that needs hot reloading would still go through a different system. And so it's like, if I have to build two different approaches, have I really made it better by doing it this way? If I'm going to have to build something that has like the downsides of hot reloading or the downsides of a plugin system in some parts of the code base, why don't I just build all of my modules using that same approach so that they at least all have the same pattern? So that's kind of where we're ending up, and I'm just testing out how that works. So the downside to doing that is that when you go to build a plugin, so that this is our pretend plugin, then I'm gonna need some kind of a way to automatically do this, right? The user doesn't want to have to type out the code that ensures their plugin will load the base somehow, right? Yeah, it's almost like I would love the magic to work, but the problem is the magic is a little bit too far outside of my control, and it's not magic enough. If DLL import export could also support runtime linking, I would be a lot closer to considering it. Like if it could, let me just pitch to you all, because I know sometimes I have people, we hang out in the handmade community. There are people who work on operating systems who think about this kind of stuff. Let me pitch to you what I'm thinking a user, I'll explain just in a minute JVS Tech. Let me explain the thought I have. As someone writing a user space program, if you're out there thinking about how to make better operating systems, let me tell you a little bit about what I want in this particular problem. I want languages to be able to say something like this. I want to say, I have a header. Let's just build an example of this. I have base.h, right? And in base.h, I have functions like void, single, print, and ink. And I don't mind if I have to mark that up with something like base shared or something like that, or func shared, right? I somehow mark that up, or I have its namespace to Mr. Forth shared function, right? And then I'll go ahead, I'll even take on the burden of saying like, okay, this is a DLL export, or, in other cases, this is a DLL import. Or it doesn't have to be called DLL, it could be dynamic export, dynamic import, or, runtime export, runtime import, so we can avoid those overly relative terms. And then, and this would be like, when do you do runtime export? Well, this is when you are Mr. Forth defining base, and if you're not defining base, then you're importing it, right? You're depending on it. Right, so I'll do all that. But then what I want is that the loader, that this could generate something like a relocations information of a particular style. The kind of relocation information it would generate would be that whenever I call that, right? So somewhere I have base.c, and base.c is, let's see, base.c is something like this, right? This, maybe I have to put Mr. Forth shared again. Maybe I don't know. But you put something like this, and if you are defining base, you would build this and this. If you are using base, you would build this, but you wouldn't define the defining base macro. So you would get the import version instead of the export version, right? Something like this. I don't mind having to do that much. Where it would be nice for this to start kicking in a magical way that is not possible here on Windows, and I don't think it's possible over on Linux either, although we haven't gone and played with it yet, is, okay, so I'm going to do this. Let's say I want to be able to, at some point, say, okay, I'm talking to the operating system now. Operating system loader, load library, base DLL, base, base library, whatever you call it in your operating system, right? Don't care if you change the signature here. We got to deal with the changes in the extension name on an operating system by operating system basis already anyways, so whatever. But once that's loaded, I would like for it to automatically, I would like to, at runtime, say, hey, I'm loading this library in. I would like for it to look at the exports on that library and go, hey, I'm noticing that you have an executable running here, or a process. You have a process, and some of your the symbols that you depend on are still unresolved, right? You created a process with unresolved symbols, and you just loaded in a library, and I'm seeing that this library is exporting some symbols, and you are waiting for some symbols to get resolved. I'm going to go ahead and cross-compare and see if we can, while we're loading this library, do some relocation to patch up these function pointers here and here, these function calls, to have them go straight into the library you just loaded, right? And I'll go ahead and do that fix-up for you. And if you later, and a few other things, if you were to call this before we did the load, then there should be some way for it to go, oh, that's a crash. Maybe not a ugly crash, but a crash that's like, hey, this process just tried to call an unresolved symbol. Here's the name of the symbol. This is a developer level issue. They should have loaded this library before their code hit this path. This is just a bug that the developer needs to deal with, right? It's not supposed to be pretty for an end user, but it's just like not mysterious. Like we can just patch that into some kind of the binaries we generate could have the error messages in them. The operating system could help or not. That part doesn't matter too much. But there are before the relocator runs, these have the ability to be pointed at something that will cause a pretty crash, or they could even be nulls, and the pretty crash is just whatever the default crash on the operating system is. Okay, and then it should also be possible to unload these. Unload library, right? And here's your library handle. Here's your library, right? And when I unload the library, it should go, oh, this library was providing the link for all of these symbols. I'm going to again relocate them back to the pretty crash handler. And that way I could do hot reloading, right? I could reload my base.library as many times as I want, and the loader, right, the operating system built-in runtime relocation resolver is mutating my code for me to make sense of these function calls. I don't see why that's not a thing, right? That's basically what I'm doing manually, anyways. I'm manually making that happen whenever I build a runtime hot reloader. If you don't provide it in the operating system layer, I'm just gonna do it anyways. But if you provide it at the operating system layer as a part of the way the loader works, that it tolerates unresolved symbols at load time and only creates an issue if we reach an unresolved symbol before a library resolved it. And if it can dynamically keep track of who has resolved this symbol and unregister it and re-register it as necessary, then you solve this problem in a deeper way than what's possible in current operating systems. So just a thought. Anyway, let's get back to this experiment here. Okay, JVS Tech asked, I apologize profusely. No, don't worry about that. You're good. What's the problem that you're trying to solve? Yeah, let me explain. So I have a thing called a base layer. The base layer has features like memory pools and a stream of logging data, various shared data structures. Global shared data structures live in the base layer. And as long as I have a single executable, this has been fine. As long as that's how it's worked, that's been fine. But if I start having things where I have an executable and a plugin system, or an executable with some core features, and then the rest of the application is in a hot reloadable DLL, if I want any kind of split into exe and DLL, and if I want to use my base layer on both parts, then I run into a new nasty kind of problem, which is that they each have their own copy of the global variable. And so in order to avoid that, it's not good enough to have a copy of the base layer in the exe and a copy of the base layer in the DLL. Instead, what I want is at least some parts of it, like small inlineable functions that don't rely on globals, those can safely have separate copies in each spot, if that's the way you want to organize it. But for at least bigger functions that are accessing these global data structures, it's important that they all link to the same instance of the function, that one instance of the function sees one instance of the global variable, so that instead of having my DLL log and my exe log be two separate data structures, that they collapse into one. And in order for that to work, it's not good enough to just compile the code separately on each binary. Instead, they need to dynamically link to each other. And so one of them provides the real definition. Part of the design problem here is deciding who defines the real one. And that's a part of why I want a DLL. I want a sort of just a set aside, separate binary. It's like, this isn't an executable, it's just the real one. And everyone else, whether they're an exe or a DLL, grabs access to the real one through some kind of automated process. And so the DLL import thing we were looking at, declspec DLL export, DLL import, is Microsoft's attempt at something that kind of automates that. But it automates that in a very rigid, locked-in way that actually doesn't work for plugins or hot reloading. So its utility is sort of minimal for me. It's useful in the sense that all of my plugins could still lock into this one base layer if they all agreed on which one they were linking to. Which is conceivably possible, but if I'm going to end up needing to build a plugin layer that works through a different kind of linking anyways, why bother having 3 tiers of linking? There's like static linking, and then there's dynamic load time linking, and there's runtime linking. Why bother building all 3 layers if I know I'm going to end up building runtime linking for some things? So I'm kind of deciding I don't like these load time linking features because they add just another variation to the system. But the problem I'm solving, to finally finish answering your question, the problem I'm solving is not wanting duplicate data structures once I start building things like plugin systems or hot reloading systems that split my program into multiple binaries or modules. And since I'm going to do it through a dynamic linker, through runtime linking, the next question becomes, how do I minimize the complexity of bringing in the runtime dependency, right? And so what I'm thinking is the base layer, I'm trying to sketch out what I think the base layer would look like. The base layer would look like this, and like this. And so Win32 base can actually go away. What we would have instead is just base.c. And base.c could even include base.h and define. This is only partially correct because, like I said, there's also the possibility that you would want some functions to be inline statics, and so then you would still want like another layer of split. You'd have the header that defines all of the functions and mark some of them as shared and some of them as local. You'd have a file that defines all the shared ones, and that just is the target for a particular DLL or shared object. And then you'd have another file that's the definitions for the inlineable small functions, the ones that don't need this dynamic linking. And there are advantages, right? If something is a very small function, if it's like a little minor constructor, it takes in a couple of parameters and does a little logic and arranges them into a struct for you. Having that go through dynamic linking, not only is it making the dynamic linking API do more work, it's also slower to call things that way. Things that could be inlined can only be inlined if they are seen statically. So you don't want to mark things as needing to go through this shared linking process if there's not some good reason for them to do that. If there's a good reason for it to be inlined instead, you want that to be possible. In reality, what I would probably do is just have base.c and have like an if defined, something like the big functions or the link shared functions, shared definitions. If defined shared definitions, then this, and then you always include, here are your inline, if not defined, inline functions, definitions, local definitions, something like that, and if defined local definitions, void make thing, int, right, whatever it is, right? You'd have something like this. So I wouldn't necessarily need multiple files. I could make my libraries still 1 or 2 files this way. But this is the core idea of how the dynamic linking part works. So this is the base layer. Right, so this is decal spec DLL import. And this is, error. We don't define those this way. So then what happens is we only actually declare them this way here. We then need a thing that's like, if this is not defined, or if it is defined as false, so the negation of that case. And then we would have something like define x as name return parameter, return name parameter equals 0 with make it into a function pointer, right? And then you would have include base xlist.h, right? And so then you have another file here, base xlist.h, that just looks like this. Single print and save, void, okay? So you still want the DLL linkage to be specified in both spots. That's okay with me. This should be export, not import. There we go. Okay, so when we build base, we say, hey, include base.h here and use the DLL export mark. And then if, do like compilation error. If someone tries to mark something as shared when we're not actually defining the base, that would be, right, this right here would be a global variable, so it could be like Mr. Forth local, right? And Mr. Forth local just means static, right? So the static turns the variable for variables. When we mark something a variable as static, what we're saying is don't even put this through the linker, right? Compile this in within this compilation unit and then forget the symbol name. Which is good because this right here will then be visible within this compilation unit as a function pointer. We might also want to say, hey, we don't want a separate static copy of every function pointer. We want a dynamic, we want not local, but like linked. So shared links things across exe and DLL, whereas linked could link things across one compilation unit and another. And then we would have to do this, right? And so this starts to get more complicated, but you could imagine like, okay, so here's the name of the function. It's declared everywhere. Someone somewhere is going to have to define the real one. So if we're not defining the base layer, we have to have one spot that defines the base layer. Well, yeah, you still need 3 tiers, which is super annoying. Right, so instead of defining base, this is Mr. Forth build mode what do I want to call it? Mr. Forth build mode shared. I mean, it could be really specific. Mr. Forth building DLL. Just get literal about it, right? And then if you're building the DLL, you do it one way. If you're not building the DLL, then you just drop down to the X list. You keep the X list in parallel with the header here. And then if you are if you are building an exe or a DLL with multiple compilation units, then one way to do it is to have each one have a static copy of all the variables, but then you have to initialize those, right? So if this is a list of global variables, right, got 20 API endpoints available. If those are all static variables, static means that they have a separate copy in every compilation unit. And that means each compilation unit would need a chance to initialize them. And their initialization that way would be it would be highly redundant. There's a couple ways we could do it. Okay, I'm going to show you 2 different ways we could do it. One way we can do it is to say we have this list of global variables, right? We have a list of global variables. They are not defined locally, so there's local, there's linked, and there's shared. Local is static, linked is extern, and shared is DLL export, right? And so we want to link these so that there's only one copy of the global variables in any binary, in any executable or DLL, so any binary or any module where we're not the one that defines the shared stuff. Instead, the shared stuff becomes these linked global variables. If so let's say Mr. Forth building shared Mr. Forth building linked. So if you're building the linked stuff, I'm gonna stop looking at the values of these just to simplify the expressions a little bit. Then if you're building the linked stuff, then that means you need to set each of them to 0 initially. So, okay. Let's look at Win32 main. Instead of this pretend base layer and pretend loader, we want to be able to just say, okay, include the base.h. Since this is the main compilation unit of this binary, let's say, you'll have to say Mr. Forth building linked building module building shared. Okay, yeah, I like that. That name's fine. It's a little confusing still. Here you're building the linked version. And so you, whether, as long as you're not building the shared version, you declare the variables. If you happen to be building the linked version, you also define them. And do that also over here in the library. So this should not build, but the reason it should fail should be that base load doesn't exist. Okay, so now if I am the exe and I included base.h, so here's the list of the extern variables. Here's the definitions for them. There should be one copy of this function, but it can be visible. Well, I guess this one, if we're not building the shared version, then instead the only shared function is base link or something like that, right? I called it load before, but base link, okay? And then if we're over here, yeah, I guess I'll just put this all in the header for now. It's not my favorite way to do things, but if you're building the linked, then we'll define base link void as, and this is where we'll grab, we end up having to grab into Windows in order to load the library. And we have to get proc. Then we're going to define x nrp. So we set n equal, we do get proc. We want to set the variable named n. We want to use the library named base, and we want to use the name that's the string version of n. And so then we use the xlist again. So that should load all of the variables. And we need a semicolon. Okay. And so here we're saying, hey, give me the linked version of base. And the linked version of base is giving us the entire API of the base, but the linked function, the shared functions here, get replaced with global function pointers that get loaded off of the library base DLL. So So the only wrinkle is to the user. The only wrinkle to the user of base is if they're using it as a dynamic link library. Right? If they're dynamically linking in the base functions, then they have to call this base link to get it started. So that's the only wrinkle to the user if you design it this way. They also have to do that anytime they load a library that uses the base, right? So if I say, hey, here's a DLL I want to load, and this DLL has a dependency on base, then it needs me to call base link. Okay. So that's an option. And you see the Win32 library automatically defines base link because that's living in base H. Right, so that got defined. It got defined as an export. So it was able to. We were able to find it. We should actually run it to make sure. But yeah, so that works. The downsides to doing it this way: one, the base layer now contains within it this. So really, what would have to happen is this would get abstracted into an operating system layer. Like if I wanted to keep this something that could live on a per operating system layer basis, then the question is, what can I do to write this in such a way that the operating system specific stuff doesn't have to appear here? Can that be done? Can that be done? It's kind of tricky. It's kind of tricky to see how that could be done. The base layer implementation I think if you don't have an operating system abstraction available to you, then you would never be able to do dynamic linking anyways. Right? Like if you're using the base by itself without access to the dynamic or to the operating system features, to the things that are controlled by the operating system and that need to be abstracted on a per operating system basis, that one of the things that has to be abstracted on a per operating system basis is how you load dynamic libraries. And so you wouldn't be able to link to base this way. You would have to be linking to it statically, right? Like as a Unity build, which I still want to support. And the way that would end up working out is here we would define Mr. Ford base shared as just being static. Right, everything would just be static, and which things we include would have to be tailored to that. Man, the fact that there's 3 tiers here is a little annoying. One of the tiers only has to be built once ever to build that DLL. And then the other 2, we already have 2 ways of building base, even if we didn't do this. So like it's not actually a new one that the user sees, but it's a new one the implementer sees in terms of how they have to organize all of this, right? It's starting to get to be a lot. Now the way this would work, if you can't see the operating system layer, this still would want to be defined in each DLL. Well, this is where what we could do is use the struct version that was suggested. So this would be like this, base function pointers, right? And in here, we would define all the same things again. So here we have global versions. Here we have members of the struct. Here we would say here are the function pointers. You wouldn't need this because you would get this pointers struct passed to you. Call this funcs. And so instead of loading the library and doing the get proc address, you would just do n equals funcs n, right? The global variable version of n gets set from the function pointers version of n. Okay, so now base function pointers that might want to live up here. So here's our base function pointers. When we are building the shared version, we would just build them like this. And then we would have one special function in the base yeah, we'd have one special one that would go like this. Right? And so that would come over here and be defined via the XList like this. We'd have a local base function pointers, which is initially null. If we might also have a, you know, init equals 0. If not init equals 1. Use the XList again. This time we fill funcs from the functions that we actually are able to see, because we can see the functions defined here now. And then we return the functions. So what's different about this, as I'm thinking about it, is this has all the same restrictions as like this doesn't enable base layer hot reloading unless you're willing to go and call base link, right? You'd have to hot reload your base layer, and then you'd have to call this again, and then you'd have to call base link on all of the other modules that you have and on the exe. I don't know. Sorting this out is always a little bit nasty, but it feels like, man, the magic of DeclSpec in DLL import does feel a little nicer than this, because it's basically doing the same thing. It's statically setting this up to, statically setting up the libraries in the exe to see into these functions. And this is doing the same thing. Like they can't be changed once they're set, except now I have to manually make a couple of calls. I have to somehow get to the point where I call base function pointers off of base. And so here, this doesn't work anymore because baselink needs the function pointers. So how do I get my hands on those function pointers in the first place, right? It's nice that I've defined it, but how do I get my hands on that? Base funcs. So the exe needs to get its hands on base funcs, and then it can call the base link on all of these. But how does it get that? Well, it's going to need to call base function pointers to set this. And in order to get its hands on this, it's going to need to look into... Yeah, it's going to have to do something like this, right? Now we need to manually load base. We're going to need to base funcs void base function pointers get proc, get the base funcs, base function pointers, base function pointers, base function pointers. So I call base function pointers to fill in the base funcs, and then I can base link. right? So that gets the job done. This and this could go and live in the operating system layers. So this would hide behind the operating system abstraction, and it would turn into OS base load or something like this, right? And then here OS library load would look like this. And if that library happens to contain the Mr. Forth base link function, then it would call it with the base funcs. Or it could be like this. It could go like this is going to do OS library. Right, so this is just sort of pretending what the OS abstraction will look like. It could look like this. Library and then OS library link base. Right? It could look like that. So if it did look like that, then this would go away, this would go away, and so you would set up like this. Now we actually already have, in the way I have like OS main in it, so that could actually hide inside of OS main in it and be completely automated. And then this is just an extra step you do when you load a library, if it's a library that you know is supposed to support, or is supposed to, is the kind of library that wants base linkage. You could just also say anytime we load a library, we check to see if it requests base linkage and then do it automatically. And then we would get back to this, right? This would be, the only thing we don't have here is then lib begin is like an OS library get proc through the abstraction. Lib begin, right? So if I write, let's rename this to, let's rename this to main.c, build.bat. We'll just bring in library.c and main.c now, and these can be include os.h. So let's see, this would be like, this would be like, we need a, let's just make this a bunch of static functions for now to get it done. OS library, so OS library is just a way to say void OS library load. Library DLL. OS library load means load library a name. Okay, so this is going to be include Windows for now. Static OS main init is going to load library base DLL. It's going to, we want this here now. It's going to get proc on, let's see, we want this guy. Base function pointers, base function pointers, right? And let's see. We're getting there. The base function pointers. All right, so once we have that, we can call base function pointers, and we'll have, I'll have to think about if the staticness here works or not, but let's pretend it does for a minute and then come back to it. Maybe the operating system layer needs to undergo like object layer link, the linker level linking, link time linking. But one step at a time here. So func putters will live like that for now. So it gets our base function pointers and puts them in a thing that it can see. And then this is going to go okay. Now take a look and see if we can find base link. If, so base link has this signature, library base link. If we try to load library base link through the library, base link, at the end we're going to return the library for someone else to use. If library base link does not equal 0, then library base link is called with the base function pointers. So anything that defines, any DLL that defines the base layer itself will bring this in with it, and therefore mark itself as something that needs this special linkage, right? Now, if the DLL gets built for static linking, then it's just going to have a bug, right? It's just going to be like, that'll work, it'll build, everything will link and run, but all of its global data structures won't fuse in. So as soon as you start doing this, if you use the library with that static linking, you run into that problem. Static linking shouldn't be the default. It should be a thing you ask for when you are building a standalone. Although better yet, we can also just not support static linking, and you won't notice, because the default, if you use it as if it's static, will basically be the same thing. If you really, really needed to, you could just say like, hey, define both of these as static, and it'll just define the whole thing in one go for you somehow. I guess the big difference is whether or not it pulls in the definitions for these things that would otherwise go to a DLL. You might want a version that's like, yeah, so there is always going to be this possibility of saying like that there's a bug. I guess the default will be that it sets itself up for linkage. No, I guess I do it the other way around. The default is that it assumes static, and then if you're building a plugin or something, you just have to know to mark it as, hey, this is a, this is an importer. This is importing the image of the base, and not actually defining it locally. I think that's the best way to think of it. So OS main init will set up the function pointers. The library load will load the library and link it to the base layer. Got to rebuild this one, but let's clean this. Clean is not catching the DLLs. There we go. So library can look like this now. Although library doesn't even need the OS layer anymore. Here's the library, here's the name. this is get proc address. Or why don't we just use the get proc macro to help us out here. Result H module library name. Return the result. Okay, doesn't look like I parameterize the return type, fair enough. Right, okay. There we go. Cool, so let's clean build dir main didn't do anything. Let's walk through this. You guys are gone. The name of the executable has been changed to main.exe. Show me. Main init, base loaded, base function pointers, that loaded, base func putters, that loaded, single print and inc, that's null, because there's our problem. When I do os main init, I need to also call base link for the exe itself. The exe wants to see the base func putters. So when we're doing os main init, we load the base layer. We grab its linker function, like that's the function that'll help us get all the other functions, and then we call baselink. So baselink locally takes in that struct and populates its global function pointers. And so this should actually set single print and inc so that it'll work. There we go. Now, does that work? Cool. So our usage code looks like this on the main, right? The user gets to see, oh, I do the os main init. This was already required for anyone using the os layer. And the os layer is now required if you're using a dynamically linked base. So if you want an exe DLL, you have to talk to the os in the first place. So you'll already have to be doing this. In order to load the library, you load it through the OS abstraction, and so that automatically handles linking to the base layer for you. And then the library doesn't know anything about any of this going on. It can just do, right, it can just mark itself as having a shared function. It implements that. It actually is implementing something that's like, let's have it run. So lib does a special thing where it does print and inc 3 times, right? And so we get, boom. Yeah, so there's, right? 3 from the library and the 2 from the exe. They share their counter, and they are able to call to this base layer function, where our pretend base layer just is containing, this is the main API, this other function in the base layer is the thing that helps with linking, the runtime linking process. Okay, I think that proves that this is automatable to a degree that completely hides it from everyone who I count a user. The user of the library is either implementing an executable, like a main program, or a plugin. Either way, they're using the base layer. And if they are implementing an executable that manages plugins, They might also be bringing it. They'll also have to be bringing in the OS layer. These two in conjunction are enough to hide all of the base layer linking, and then all it takes to build each of these is you build your main as an executable, you build your library as a DLL, you build or your plugin or your hot reloadable section as a DLL, and this thing here you also just build. You have to have a special target that's like the base dynamic base target, right? That seems pretty good. That seems at least like a livable, a way of life we can live with. So, nice. So that's Windows. I think that abstraction will work across both because we don't know what the loader does on Linux automatically. We could go check that out. But ultimately, the conclusion we would come to is that we still want to manage it at runtime. And so we would still want to manage it through runtime linking. And so the rest of what we would find here in the Linux side is going to be pretty much the same. We can actually like try it out though. Let's just play around. So if this is what the Windows one looks like, let's build a Linux version, right? So let's do clean. Let's do build sh. Oh, I forget the syntax for this. Let me go look at one of my other bash scripts. Mr. Forth bin build fly. There it is. Research Lincoln load. Build. Okay, so this is going to go through the same basic thing, except it's going to go through GCC now. So we need one that builds main from main.c. We need one that builds the library from library.so, right? And we need one that builds the base.so. Now the question is, how do I tell GCC these are shared objects? GCC output shared object. What is it gonna take? All right, so to make a DLL looks like or a shared object looks like I want to do these two things. Now let's pop into our WSL thing here. We're going to back up. We're not in WSL experiment anymore. We're going to go over to Mr. Forth research Lincoln load. And we want to see, can we build SH? Okay, we got some issues. Let's see what the issues are. Okay, so in Linux mode, let's see, how can I don't want to have to build a whole context cracker. So I'm just going to manually change all the things that are Windows specific with a like map, maybe like this. There's Windows, here's Linux, right? There's Windows, here's Linux. Base.h. There's Linux, there's Windows. Let's just do it this way maybe. So there's Windows. Now the Linux version, let's see, GCC mark function for shared object export, DLL export. See if any of that helps you find shared. Export. Is it this one? This is what the first thing that came up on Google search was. Visibility. Attribute. This is saying attribute DLL export. Okay, this is if you're on Windows. Let's assume that it's going to be the Linux version. Visibility default. Really? Is that what you said over here? I'm not sure why I didn't show what I'm seeing here. But yeah, it's saying attribute visibility default everywhere I find it is sort of the equivalent to DLL export. Let's see what that does. Okay, closer. Base.c. Yeah, sorry. Let me bring in standard IO for you. That was happening automatically on the Windows one. Who's including that? os.h. Windows. Right. So this Linux one we haven't actually re-implemented yet. It's going to be something like this, though. We're going to want to find that function pointer. Okay. So that builds. Let's go and find the Linux equivalents for these now. I could find this in the 4Coder source. I think 4Coder did this. So let's take a look. 4Coder. Platform Unix. Library wrapper. DL open. Oh wait, this looks like it's probably not actually getting hit. It's probably not getting linked. Is it over here? No, that's not happening either. Maybe it's just in Linux then. And 4Coder code is wild. DL open. There we go. All right, so that is the library. base.so base, and then get proc is dlsim. Base function pointers. Base function pointers. Okay. I think that should be all I need. So library equals, and then here's the name. Library base link. Base link. And this is just result. And the name. Okay, this is, oh, this is in the Windows build, but I want the Linux build. RTLD deal open. Okay, right, so you're not seeing the name. So, how to find it? Let's do DL open man pages. Header, header, header. Here we go. Does that get us all the way there? There we go. Okay. Okay, so if I look, let me do a couple steps here. I'm gonna clean everything. Take a look. Is there anything else left that didn't get cleaned? So SO and main need to get cleaned now. SO delete main. All right, so if I build, nothing happens. If I build this way, then we've got main, we've got library SO, we've got base SO. Okay. If I /main, I get segfault. Okay. Oh, okay. Let's see if we can debug why we get segfault. Surely, if it gets far enough to print this, that would make sense. So let's just see, hello? Hello? You know? Hello? Did we get, hello? Did we get this far? There we go. Okay, so we get this far. OS main in it. What's going on in here? Are you, surely you're getting this far, right? Yeah. Are you getting this far? Wait, here's a question. How is dlsim supposed to know what library I'm talking about? Yeah, this is some nonsense. I don't know why I thought that made sense. No. What needs to happen here is that this gets the base, and this right here gets the base function pointers, and we can cast that like this, right? DLSim is gonna, yeah, be marked with a void pointer. So it's returning a void pointer. We're taking the L value and turning it into a void pointer L value. Same thing here. You are the void pointer L value. The library goes here. You are the L value, void pointer L value. The library goes here. We build and we run. So we get to hello without a seg fault. So we got that far without a seg fault. Do we get this far without a seg fault? No. So base function pointers didn't come back so when we look at base.c, base function pointers is marked as shared. Base.h says that shared should be this attribute visibility default thing, yet I'm not seeing it. So I'm not convinced that that is the correct way to export. Let's turn to forcoder again. And let's take a look and see where might I find where might I find something that generates so fored API definition might be the right place. Okay, if it's not there, then it's in definition.cpp. API function, no. API list check, definition, definition error, definition. How are there so many? Do I have overloaded functions in here? Is that what's happening? Definition error. Generate API includes. Generate constructor. Generate header, generate API master list. Okay, thanks. That's maybe a more direct way to get there. So let's see. nm base.so. Single print and inc. Base function pointers. It says capital T. That dash dynamic, let's try that. Dynamic base SO. It looks like it sees that. Base function pointers. Let me just double check DLSim. Let me do Yep. So it's not finding it when I do DLSim, that's for sure. It's loading something into base. This is doing something. Well, do I know that? Would this crash if it was a null pointer? to be sure. No, okay. So it's not successfully opening a shared object. Base SO is here in this path. Main should be able to find it in the path. So it's not necessarily that it's... Let's look at DL open again. File name flags. AZ. Okay. Look at DL error. Thanks for the tip. DL error. Can I get just them all on the same one? And 7. Okay. So we're just gonna do this. Okay. Yeah, it's not finding the file path. So base SO isn't resolving. Isn't it supposed to search inside the current directory? Or the same directory as the main executable? Or does it only take full paths or something? Yeah, I can give that a shot. It looks like search path doesn't actually include the local directory by default. So let's try /base.so and in main /library.so. See if that changes anything. Good idea. Hey, there we go. Okay. Cool. So, no, I do not mind you backseating at all. Linux is miserable. I'm happy to have someone backseat me through the process of Linux. I wish Linux itself would backseat me more, but you're doing pretty good. Okay, so that works. It does the right thing. So the point is, I think we've constructed, both discovered and constructed, a decent way to abstract between the two operating systems. I originally had on my to-do list to go and do all the same checks. We've done this with these two. So I have my base layer living in the shared object and going out to the executable and other shared objects. I didn't try this, but I'm pretty sure I don't like that as a design anymore. So we can just say we didn't run that experiment. We didn't spend a lot of time figuring out what we could do with the loader automatically. And it might be interesting to know that stuff. You know, it'd be kind of cool to do the research, and we're close to having that answer. But I think what I would ultimately conclude is I don't want to do it that way. So my heart's not in it anymore, you know? Like ultimately what I would want, it would, so here's the one thing. If it worked out that on Linux you could write code so that you didn't have to write the manual linkage stuff, you just define your symbols globally and it automatically does the patching I was talking about earlier, I'd be very surprised if it can do that. But if it does, that would be cool to know, but I still couldn't take advantage of it because I wouldn't be able to do it on Windows. So maybe we just check and see if that's the thing. But okay, so there's the main idea. Let's build a second little experiment here, similar to this one. We can simplify a little bit. So we're just checking. We're just checking if we can do. Let's see. We want to do the same thing we did in os.h. So give me this header. Give me. Instead of base SO, we're going to call it Linux base SO. And we're going to say, hey, I want Linux base.c here. Build sh. Let's comment out this experiment. Yeah, Terry's Python. I'll summarize all of this and put it into an article or something like that. Maybe a video. Just summarize what I've learned and my conclusions and stuff. For sure. I won't have it. It just won't be the only artifact of the experiment. Okay. Linux library.c, Linux base.c, Linux base.so, Linux main c, Linux main. All right, so there's that stuff. Linux main is going to want to find something like single print and ink, and you're going to define it. We're going to have int single x equals 0, printf. So you're going to want you to know about standard IO, and you're going to say, well, let's see, our library, no, our pretend base over here already has this implemented. Let's just drop that there. So there's our base layer again. Now our base layer is living in the dynamic side. And let's simplify down here. So we did the abstraction before we did the Linux simplified version, but let's roll it the other way so we can see the hard concrete version of the Linux one. So this marks it as an export from the shared object. I kind of get the feeling there's just not going to be any way to get the GCC to accept this, right? Single print and ink, run that a couple of times and see if we can get it to call this without having to manually load it at all. Let's see what happens if I type in like GCC DLL import similar feature. All right, let's just see. So if I do build sh, it's set up to build those two things. Let's see what happens when I try to build them for starters. Okay, so sometimes it can be nice to see the stages, and GCC doesn't do the thing that CL does where it prints the name of the file it's building. So I'm going to just put that in there. So base.c gets built with no problem. It's main.c, undefined reference to single print and ink. So the question is, how can I convince it? how can I convince it that that is going to be... So I think what it wants, I'll tell you what I think it wants. I think it wants something like, yeah, we have that commented out. I think what it wants is something like, after we've built Linux base SO, that we put it in like that, maybe? Or maybe like this, I'm not quite sure. Let's try a couple of these things and see what happens. Okay, so when I put it in like that, it just accepts it and links it, right? So now, Linux main, error while loading shared libraries, Linux base SO cannot open shared object file, no such file or directory. Linux base SO does exist, it links just fine, but somehow it can't find it. Right, so Linux probably, when I say you're gonna link to this, wants this to live in another directory. Add the line after the shebang line, set X. What does that do? Patrick, what is the set X for? I'm just curious what the, is that for the printing? Is that what you're talking about? All right. Let's check it out. Oh, cool. That's not a bad way to do it. Thanks. If these lines got longer, it'd get more annoying, but for now, this is good. So how can I convince it to load this? Do I need to put the shared object in a different location? Is that the only way GCC will accept, or like the Linux runtime will accept a shared object? Let's take a look. GCC shared object on input line. What does that mean? A file name that does not end in a specialized recognized suffix is considered a name of an object file or library. Object files are distinguished from libraries by the linker according to the file context. If the linking is done, do you say anything here about SO? Some targets also support shared libraries, which typically have names like lib library SO. If both static and shared libraries are found, linker gives preference to linking with a shared library unless the static option is used. There's a difference where in the command line you write this option. The linker searches and processes libraries and object files in the order they are specified. Thus, foo.o lz bar.o searches library z after file foo.o but before bar.o. If bar.o refers to functions in Z, those functions may not be loaded. If bar.o refers to functions in Z, those functions may not be loaded. Yeah, Tiberian, that's exactly what's happening. So I can tell it to build by giving it the source file and the Linux base SO. And it builds just fine. And then if I run Linux main, it says it can't find Linux base SO. But if I look at the directory, Linux base SO is right there in the current directory. So, Cypress, yep, I'm gonna publish everything that I learned today in an article sometime in the next couple of weeks, for sure. Thanks, Patrick. All right, so Tiberian says, if so, try ld library path equals ... Linux main. Dash Linux underscore source instead of just name. Cypress, if you want to find articles that come out from me, if you go over to MrForth.com, I publish my articles here. I don't have very many of them on this site yet, but when I have write-ups, I put them here. You can also sign up for my newsletter, and so you'll get a notification from me whenever I publish something like a article or a blog post. I don't know if you want to call these blog posts or what, but when I publish them, you'll get a notification. And you can find a bunch of my other projects. You can come over here and see all my open source code and stuff like that. So mrforth.com, you go there, you'll be able to find everything about this project and everything else I'm doing. Okay, interesting. So space between the two dots, LD library path equals dot space. Does the dot mean keep the existing library path? So I'm gonna ask you some questions since you're giving me tips, and I kind of half understand, but I want to fully understand before I take them. So if I do what you're saying, if I do this, a couple of questions. This dot right here, does this say something like, hey, save? Is this like kind of like equivalent to like a plus equals? Is that the idea? Like, is this saying save this, or is this gonna completely overwrite my library path and just say current directory and also the current directory with Linux main, or what exactly does this say is what I'm asking. Why does this work? Also, I'll check it out first and see if it works. Okay, so if I do I need to do this before I run or before I build? Probably before I run, right? And you're saying I should do -L. Let's see what happens when I build with that. When I build with that, it cannot find Linux base SO. Okay, so now it's building, looking for Linux base SO in paths other than the current path. If I follow your instruction to do this and then build, I get LD path equals dot slash Linux main. No such file or directory. Okay, I got it now. So the problem is when I build, if I do the -L thing, it's looking in different paths. I think that this is appropriate because I'm linking to something that's like in the current directory. The -L thing is for when you want the linker to look through system paths, I think. I could be wrong. It sounds like you know a lot more about this than me, but I'm just piecing together from what I've seen before and what I am seeing now that I think the -L... Oh, it wasn't you who suggested that. Yeah, I think that that's not what we want. So this is a local path. And then we're saying we want to do LD library path equals dot. That's saying look for libraries in the current path and then run Linux main. Let me build first and then try that. Hey! Awesome. Okay. So that confirms for me that the Linux version, let's take some notes. Here's our Linux notes. You have to link, this is for the loader automatic features. You have to link the .so Yep, okay, I follow now, Tibers. Yep. So you have to link to the SO that contains, so this up here goes like this. With the Linux one, we didn't have to do anything to mark the import. Linux main, yeah. So this is Linux GCC Linux base, we use this to mark it for export. And then you have to link that so when you build, you still have to link it. So it can't be dynamic. This also does not support the magic I was talking about earlier where it could support hot reloading. This is sort of baked in as a concept that this executable, Linux main, is going to, at load time, look for Linux base SO. So it can be swapped out between loads, but it can't be swapped out during a single process. And then you have to link to the SO that contains the export, and if this can be, it can be local. Now the issue is if I build something like that and I wanted to run it, you're saying that now I have to set this path every time. But there's a bigger issue, which is even if there's a solution where I don't have to set the path every time, my users have to do something funky, right? I can never get to a state where a user just gets this executable, maybe they download the source and build it, but one way or another they have to do something with their paths in order to run this, because it needs to find Linux base SO. And so the standard Linuxy way to do this would be to put Linux base SO into, let's take a look. Is that, am I missing something here? Should that contain something? Is that always supposed to be empty? Let's look at, you're telling me to look at rpath, echo run path. These are all empty. Patrick, we're pretty sure it's going to be linked dynamically, I think, right? I don't, what is LDD doing for me, by the way? They are set during link time. Okay, our rpath and run path are, these ones aren't environment variables. Rpath and run path aren't environment variables. Can you also tell me, is it normal, is LD library, am I echoing this wrong, or is LD library, like surely this is how you echo things, right? Yeah, so LD library path isn't an environment variable either, or it's default empty. How can I find a path where, okay, gotcha. So the interesting thing then is, okay. So we're almost at 4 hours, which is about a good time for me to wrap up, and I need a break anyways. Still, I wanna wrap a few things up nicely, so I'm gonna take a 5-minute break. I'm gonna take a quick break, and I'll come back and we'll wrap this up for a little bit. But yeah. Give me just a little bit of time. All right. All right, let me see. Before I get back to the code, what's happening in chat? Okay, so uh, I have no idea how to pronounce your username, but Pra, I'm going to call you Pra. The thing you're pointing at sounds like the path where I will find um, shared object files that are visible to the compiler slash linker when I'm building the program. Is that the same thing as the path where they will be loaded from at runtime? Like at load time, when I run the executable, will the loader look in that path for them? We'll find out in a minute. Okay, cool. Let's see here. Okay. Um, JVS Tech. Thanks, I appreciate it. And yeah, it's I don't do this. I don't really stream the most fun stuff all the time. I stream this because it almost like holds my feet to the fire on some of the this sort of work where you have to like spend time unearthing the esoteric details of stuff that feels like it should be simple. It's so valuable to get done, but it can really stink. And doing it on stream is one nice way to kind of get me over the hump, but it's gotta be done. Yeah, that makes sense. Tiber says, if you compile Linux main with the following argument to GCC, it will search for libraries in the current working directory as well. -wl -rpath origin. Okay, cool. I'm gonna go check that. I've got a lot of different recommendations coming in, so I'm tracking down lots of these. But that sounds super relevant. To what I've got going on here. I'm not quite sure. I wanted to track down this idea here. But let's see. Let's see what GCC RPath has to say. You can go away. Let's see what this says about RPath. Yeah, some of this linker stuff. I swear, like, if we could get some of this lowest level stuff, like there are all these like, new programming languages and things that build their own module systems, but like as long as the esoteric cruft lives at the lowest level, we'll never be done with this nonsense, right? It feels like at some point we have to wake up to the cost of running tool chains that don't have higher level, like that. We want our highest level ways of arranging things to bake all the way down to the lowest level in clear ways, and we're still actually sort of scripting it through these really strange interfaces. So our highest level stuff kind of punt at the and at some point and don't look behind the curtain on the low level. And so there's a gap, there's a wrinkle in the path from high level to low level. Well, Darius Python, I care. It's something I kind of want to be working on. It's hard to figure out how to break into it, but I have a couple of ideas of things to do at the level of loader and linker, and I think progress is possible. But like what Pra is saying, ultimately it comes down to you have to write a new operating system. You can skirt around the edge of that problem for a certain amount of time, but at a certain point, if you really want to cut through it and be done, you'd have to write a new operating system. And folks who are doing that are, you know, doing really incredible work, but I think ultimately reporting back that it is not, uh, it is hard to tame that problem too. And so it seems to me like we ultimately are going to have to let something go if we want to make forward progress. Like there might not be any path to solving some of this um, that doesn't involve uh, regressing for a while along the way, and I don't know how much of the world is ready to do that yet. Terra's Python. The answer is some of it is very OS, some of it is not. The part which is deep in the OS is the loader. So the linker can be anything you want it to be. You can make any file type you want go into the linker, but what comes out of the linker has to be something that the loader can understand. And on Windows, there's nothing you can do to change the loader, and on Linux, you can change the loader, but if you don't participate in the basic same structure that the existing loader participates in, um, most of Linux just doesn't work. So yeah, you do. There is a layer at which what we're talking about is an operating system is kind of like an application, and the user space programs that run on top of the application are the plugins, right? If you have an application with plugins, the application defines the interface that the plugins will use to communicate to the core, and the core then facilitates the communication between the plugins, however it sees fit. And the operating system plays that same role. And so if you don't change that, you will ultimately don't change the way pieces of programs get stitched together into processes, and the way processes get stitched together into larger running systems. So yeah, if you don't touch the operating system, you can do a lot to experiment with and show what could be better, but there are certain amounts of cruft that are just hard coded in at the operating system level that someone has to come in here and unearth the esoteric knowledge, even if you want to shim over it and make something that works better on top. And if you want to get to a world where no one has to do that, then you need to build a new operating system. And honestly, even if you built a new operating system, someone might still have to do that. They would just do it in the new operating system. The question is, could you do it in such a way that you fuse more layers together so that the person unearthing the esoterica of the operating system is getting more done than what they get done. Like here, what I'm getting done is getting some strings to match each other so that some two files will come together in a process. If the high level and lower level were not so far apart, someone would still have to deal with the lowest level, but maybe the lowest level could have more leverage. Okay. Add a directory to the runtime library search path. This is used when linking an ELF executable with shared objects. All RPath arguments are concatenated and passed to the runtime linker. The runtime linker is another way of saying the loader, which uses them to locate shared objects at runtime. The RPath option is also used when locating shared objects, which are needed by shared objects explicitly included in the link. See the description of the RPath link option. If RPath is not used when linking an ELF executable, the contents of the environment variable ld runPath will be used if it is defined. The RPath option may also be used by SunOS. Used on SunOS. By default, on SunOS, the linker will form a runtime search path. Does it... Okay, so here's the question then. What is that other part here? The dash WL, dash WI, dash W1? What is this that comes with that? Dash W. Yeah, I don't know what the if we can get back to that conversation, what is the dash W part about? Yeah, Starfleet clone. I mean, hardware complexity is a part of the reason why operating system wrangling is so hard. That like I said, we're gonna have to give something up to make progress, and I don't know where the right place is to give something up, but I think the right place to give something up has to be low enough level that it includes writing a new operating system. If we've given up the ability to write new operating systems, then we're saying we're at the end of computing now, right? Like, that seems a bit off. And new operating systems do come out of the absolute largest, most well-funded actors of the tech industry, but that means it costs too much to make progress, and we should be looking for a way that progress could be cheaper. Okay, so that's the thing to tell GCC that we're talking to the linker. Got it. Okay, so we're doing dash WL that tells it we're talking to the linker, dash RPath, comma. Now, what's this stuff about slash origin? Are we talking about... I'm not sure what that is. If I do this, do I see something? I'm not sure I understand the rest. Dash WL, comma, okay. What's the origin part about? I mean, when I read .r, like rpath, the thing it didn't tell me much about is what kinds of paths I can put there, right? So here we read rpath dir, add a directory to the runtime library search path. It doesn't say that this has to be an absolute path. So why can't I do rpath dot? Like, that's kind of where my head goes. And you're suggesting something a lot more esoteric than that, which isn't hinted to at all in this documentation. Unrecognized command line option rpath. And that's coming from GCC. Let me take a look at this again. Dash WL comma. Oh man, what was the suggestion? Why am I so bad at this? All right. Dash WL comma no space. Comma no space. So do I use commas? Do I use commas now instead of spaces because it's going to parse all of this as one command, like one argument, and then like this starts as one argument and then it processes it to turn it into arguments for dash for LD. Is that what we're doing here? Is it like this? It's still saying unrecognized command line option rpath. Let me take what you said even more literally just to make sure. Okay, so single dash for WL. It's a lowercase l, right? It's not like an I or capital L or something. And then okay, lowercase l is correct. And then you're telling me this thing about origin. Let me just put that in there. Hey, that worked. Why does it say unrecognized command line option rpath until I did what you told me? Comma slash. I don't know. That's so esoteric. How do you the $sign is being escaped. Okay, that makes sense. So this is a raw $sign after the escape gets read out. And so we're saying dash rpath comma $sign origin, and then the comma gets turned into a space when it goes to the LD linker. Yeah, this works. Here it says unrecognized command line option rpath. Oh, maybe I didn't run. Let me run it like this real quick. Okay, so that works. Yep, okay. So rpath comma dot would work. The question is dot okay? Am I wrong for thinking that dot makes sense? Because all I wanted to do was say, hey, this executable, right next to it, wherever this executable lives in the file system, right next door in the same directory will be Linux base SO. And so I'm thinking dot makes sense. Although dot could mean the current working directory, and so then that will look not relative to the binary, but relative to the current working directory. Got it. So origin, this is the way of saying, hey, wherever the binary lives. Wow. And wow. Okay. That's just so wild. All right. And if we do Linux main, great. So now I can make an executable that works the way I want. Okay. Well, that's a whopper. Linked SO so that it can be local during what? We're just. That makes sense, right? When you're doing the very standard Linux arrangement of executables, you put your executables in the bin folders and your shared objects in the lib folders. Yeah. I'll be able to turn that into an article. That much information will remind me what the deal was. So either way, this has the same limitation as the DLL export import options. But we figured out what the loader can do. And that's it. That's the whole stream, folks. So, if you are interested in what I was working on today and would like to see projects like that, whoops, I didn't mean to go to this path. You can, of course, keep your eye out on my Twitch stream. I don't usually stream on Wednesdays. Usually my stream schedule is Mondays and Fridays, but I move things around and do random stuff sometimes. So today you caught me on a Wednesday. You can come over here to mrforth.com where you'll find you can get on my newsletter and you'll get updates once every month or two. I'll be posting an article about this particular project since it was just a sort of research and reading and experimenting thing. And we've unearthed enough information that it's worth sort of sorting out what's what happens on Windows, what happens on Linux, what the compiler magic is, what the command line magic is, how the paths work and all that. We're going to put that into an article and share that so you'll be able to see the results of what we learned today cleaned up in there. You can also go over here and check out some of my open source projects and stuff like that. You can also look at stuff I've done on YouTube. You know, all of this eventually sooner or later comes out as YouTube videos. Well, not all of it, but a lot of this sooner or later comes out as YouTube videos. There's also a couple of other YouTube channels with different styles of my content. So if you come over here on Mr. Fourth Dimension, you'll find my stream archive. So today's stream plus all the other streams I've done lately are up here. You can come to my main channel where I do podcast videos and video essays and like series and stuff like that are polished up. You can go to my unscripted channel where I just talk off the top of my head about things I'm working on, particularly the Story Engine project, but there'll be other stuff on that channel sometimes. So that's all the stuff I've got going on. You can check out and keep an eye out for it. And if you've been hanging out and give me feedback, big thanks. I definitely could not have figured out all of this in just 4 hours without some of you folks in the chat. So you've contributed a lot to this, and I'm gonna try to give what you've given to me and pass it on with that article. Big thanks for that. And yeah, besides that, I hope you all have a good day. Bye.